Right, hello. I hope you guys are good. Okay. Yeah, guys, sorry for being late. Sorry for being extremely late. We're getting it down with the grade 10s today. Getting it down with you, and no one else. So, yeah. You are the privileged to be here. I hope you guys are good. So we are going to be flying it pretty real with the grade 10s here. And we're doing paper 2 today. So guys, don't harass me with any other paper today. I don't want to be hearing it. I don't want to hear it. Don't tell me about it. If you guys want to check out some stuff on paper 2, you're more than welcome. On paper 1, you're more than welcome to go to my YouTube channel. You'll find a lot of stuff there, paper 2 related. Paper 1 related, There's also paper 2 related stuff there, but you can find a lot of stuff that's paper 1 related. I've done too many live lessons on paper 1. There's too much content on my YouTube channel. You can go there. The link is in my bio. If you guys are wondering about the YouTube channel, what about it? The link is in my bio. The YouTube channel is also called Maths is a Game. Okay. It's got a white profile picture with the inscriptions Maths is a Game. White profile picture, inscriptions Maths is a Game. But go to the link in my bio if you want to go to the YouTube channel. If you go to my most recent videos uploaded there, you'll find a lot of the live lessons I've done here on the platform. Paper 1, everything from number system, to factorization, to expressions, to equations, exponential equations, to addition and subtraction of algebraic fractions, to multiplication and division of algebraic fractions, to inequalities, literal equations, word problems. I even have a video that a live lesson that I've posted on word problems. If some of you are struggling with mathematical modeling, you can check that out. And then there's functions, of course. I've done straight lines, parabola, and just mixed it about with straight lines and parabola. So today I'm doing paper 2, guys. I am not touching paper 1 unless someone sends me a big gift today and basically pulls me in the direction of helping them with something specific. If you can support my life goal with a big hand heart or a paper crane, I will stop dead in my tracks. You can request and I will basically bow down to you and attend to your request, whatever it is. If there's nothing of that sort, then I'm continuing with just what I have planned for today. Okay. All right. So mathematics paper 2, this is a session that is going to basically help those who are preparing for paper 2. So we'll start with what we have on here, and that is analytical geometry. All right. So let's take a look there. We are told in the diagram below, grade 10s. N, there it is. X and Y, as you can see it. R, 8 and negative 2, there it is. K, 4 and negative 6. Guys, when you read coordinates, you say P is 0 and 2. The X coordinate is 0 and 2. Not 0 is 2. No, we don't say such. We say 0 and 2. N is X and Y. R is 8 and negative 2. K is 4 and negative 6. So in the diagram, N, R, and K are vertices of triangle NRK. Vertices, guys, are where two lines meet. Vertices will make an angle even. Okay, but that is vertex N, vertex R, vertex K. Then we are told that N and P, N which is X and Y, and P which is 0 and 2, are points on the X-axis So we can see that on the x-axis we have n, which is x and y, and y-axis respectively. So P is the point that is on the y-axis. What evidence do you see in the coordinates that convinces you that P is on the y-axis? I'm going to repeat this again. What evidence in the coordinates convinces you that P is on the y-axis? Okay, it's one thing to say something is there, but it's another when you can see evidence from the point itself that this thing is truly on the y-axis. So TJ for real says the x value is 0, and TJ, you are for real, buddy. You are for real, for real. Very good. The evidence that P is on the y-axis is manifest in the x value, because we know the y-axis has an equation which is x is equal to 0. X is equal to 0 everywhere on the y-axis. Ne? So that's the evidence. Then we are told that n is on the x-axis. But you can see that as far as our coordinates are concerned, the evidence that it's on the x-axis is not there. But because they have said that n is on the x-axis, there is something that we can basically say about one of the coordinates, right? And what is that? One of the coordinates we can actually then state, because we are told that n is on the x-axis. Which coordinate can we give that we have not been given? Very good, Nkululeko. Very good, Alice. Again, coming in at number 3 with the right answer. Yes, guys. So though it's not given to us, we know that y is going to be 0. Then we are told at the end, PK is drawn parallel to NR. Where's PK? Here is PK. We are told that PK is drawn, so I'm going to put the arrow there, is drawn parallel to who? To NR. I'm going to draw the arrow there to indicate parallel lines. Guys, you know when you read the statement, there's so many things that come from the statement. And there's so many things you can basically come to the conclusion of based on what you are reading in the statement. But if there's no knowledge of certain things, you could read this very same statement and not come to some of the conclusions that we have come to because you don't know. So how important it is to be informed. Okay? So let us continue and look at the questions that are at hand. The first question is they are saying calculate the gradient of PK. First question is calculate the gradient of PK. So what do we do to calculate the gradient of PK? Question is, do we have the points that are needful to calculate the gradient? Everything given to us for PK? And 2, do we know the formula that we use to calculate gradient? So I can see people are saying yes, we have everything that we need. The gradient formula, we know what it says, and we have the points, we know what we've been given. So the gradient of PK can be calculated. Very easy. Let's use the gradient formula and substitute, says Kumi. And the TJ said change of y over change of x, which is very good. The only person I'm really concerned about is young MVJ, because young MVJ is saying y1 times y2. I don't know how that works. Alice is saying y2 minus y1 over x2 minus x1, which I agree with. Okay, so guys, whether you use y2 minus y1 over x2 minus x1, or you use the actual letters to basically denote the coordinates, either way, you should still get the same what? The same answer, because it's the change of y at the top in the numerator over the change of x, and the order must follow suit. If you say y2 minus y1 at the top, then it must be x2 minus x1 at the bottom. If you say x coordinate, y coordinate of p minus y coordinate of k at the top, then you must say x coordinate of p minus x coordinate of k at the bottom. Pk, pk. Or if you say x coordinate of k minus, y coordinate of k minus y coordinate of p at the top, then you must say x coordinate of k minus x coordinate of p at the bottom. So it's very important that either way you do what is required. So if we say m is equal to the y coordinate of k minus the y coordinate of p, x coordinate of k minus x coordinate of p, that's a fine formula to use. You then know that p is 0 and 2. You know that k is 4 and 6. Then you go there and substitute. What's the y coordinate of k? It is 6. Minus the y coordinate of p, that is 2. Very good, Kumi. I'm glad that you done found the answer. That's what I expect from people that are amazing there. So we have 6 minus 2 if you say y coordinate of k minus y coordinate of p. Then x coordinate of k at the bottom, 4 minus 0. Okay? Does that make sense? Oh, sorry. Oh, yeah, it's negative 6. Thank you so much, guys. I forgot there. You see, my first error there. So I should be saying negative 6 minus 2. I have brilliant people here in the live. Thank you, guys. You guys are very vigilant. Okay? You are very vigilant. From the get-go, you can see I wrote down the coordinates incorrectly. Already, I'm making mistakes. But I'm so grateful to have people like you because you guys know what should be done. So it should be negative 6 because the y coordinate is negative 6, right? Minus the 2 over x coordinate of k, 4. It truly is 4 minus what? 0. So what's negative 6 minus 2? That gives us negative 8. 4 minus 0 is 4. Very true. It should definitely be second nature for us to double check. Okay. Yeah, guys. Always make it a point. Very good. Very good. I like what you are saying, TJ, for real. It should be second nature indeed to double check. It happens sometimes that you just rush, and then when you rush, you can make mistakes. So let's make sure that when we have identified the points, we write them down correctly. Otherwise, we will be the ones that will lead ourselves to a loss of marks. When you get that gradient of pk, all right, you can see that the fact that it is negative 2 makes sense because when you look at this line, it's a decreasing line. So it should be having a negative gradient. So this makes sense. Okay, gradient of pk is negative 2. We should have all gotten that. To those who got it, okay. Move on to the next question. Determine the coordinates of n. Ayaka, hello.
Hello, sir.
Are you here to answer and determine the coordinates of n? I see you requested.
To determine the coordinates of n, I requested a long time ago. Like I was starting now, so I'll try.
Okay.
We can try. So it's a New Zealand one statement.
So the statement is here in the diagram below. N is x and y, all right? R.
So O, P, K, and R and R the parallel lines.
Yes, PK is drawn parallel to NR as it says.
So a gradient of parallel lines is equal.
Okay, gradient of parallel lines is equal. So which lines they have the same gradient then?
It's PK have got the same gradient with NR.
Okay, so the gradient of PK you are saying is the same gradient has the same gradient as NR.
Yes, and then we can calculate by using the equation of a straight line, which is y is equal to mx plus c.
Okay.
Then
So
must
by that you want us to find the equation of which straight line?
of ONR.
Okay. So you are saying we are going to find the equation of the straight line NR. Then after finding the equation of the straight line NR, what do we do?
We will substitute the coordinates of R to get the C value.
Yes.
Then we already know that y is equal to 0 in that line. Then we're gonna substitute in the equation of a straight line by y to 0. Then we solve for x.
Oh, I see. So you told us that y is already equal to 0.
Yes.
Okay. Why did you say y is already equal to 0?
Because a point in a x-axis. I don't understand. I don't know how to like explain it, sir.
Okay, you said it. A point that lies on the x-axis. You know that on the x-axis, y is equal to 0 everywhere on this line. Yeah, because the equation of the x-axis is actually y is equal to 0. Everywhere on this line, y value is 0.
Yes, sir.
Yeah, so even here, at this point, y is 0. Even there, y is 0. Even there, y is 0. So you have said it correctly that the y value is 0. Okay, so I like your method. It's just that, of course, with any method, so we can go ahead and say the y coordinate is 0. Okay.
Yes.
That's because the point lies on the x-axis, you've said. So we already have the gradient of pk. Your method suggests that we find first the equation of nr, you've said, right?
Yes.
Yeah, so let's go ahead and do that. Y is equal to, obviously that would be negative 2x plus c. If we are wanting the equation of nr. So I mean, that's a method as well. Then you said we substitute what to get c?
We substitute coordinates r, which is
so we are going to substitute the coordinates of r, which are 8 and negative 2.
In the place of y, I'll put negative 2.
So the x value will be 8 and the y value will be negative 2.
2 is equal to 8.
Then we're saying that we are going to solve for c.
Yes, sir.
Okay, so negative 2 is equal to negative
16 plus c.
Then
we transpose. 14 is equal to c.
14 is equal to c.
Yeah, then we write the equation. 2x plus 14.
Okay, so that's the equation of this straight line of nr. Then you said there we're going to let what?
Y is equal to 0.
So we let y be equal to 0 because n is a point that lies on the very same straight line, and here the y value is 0. So we let y be equal to 0 so that we can find the corresponding x value.
Yes.
So 0 is equal to negative 2x plus 4.
14. 14, sir. It's 14.
14, eh? Oh, yes. Sorry. My bad. My mistake. Very good. Thank you so much for that.
14.
2x is equal to 14.
Then we divide by 2 both sides.
Divide by 2 both sides.
Divide by 2. 7. X is equal to 7.
X is equal to 7. When we look at the logical answer that we've got of 7, does it make sense when we look at the point, the fact that x will be equal to 7, given that r, the x value for r is 8. In other words, that means here 8 is here, then the number before is 7. So does this value actually make sense?
Yes.
Yeah, it makes sense, you see. So that's one of the things that basically for you as a person who's doing the calculation, it will give you confidence to say, my answer is sensible in light of the position on the x-axis for the given x value. So this is one way of doing this question. This is one method. Okay, one method. Someone else, when looking at the same question, would probably, like you said the gradient of pk is going to be the same as the gradient of who? nr. So remember, you have the coordinates of n, but you are missing x. So you've already calculated the coordinates, the gradient of pk, which is -2. So if you take the gradient of nr, you say y of bani of n, which is basically the 0 minus the 2. So you are saying 0 minus 2 over the x value minus 8. Okay.
Then you
get -2 is equal to, what's 0 minus 2?
0 minus 2 is equal to 2.
Yeah, it's going to be 2 at the top over the x minus 8. Then get from here, we can do cross multiplication, right?
Yes, sir. Or times by both sides.
Or we can say that
x minus
multiply by the LCT, which is x minus 8, which is the same thing. Shortcut is cross multiplication.
Yes.
So then we say minus 2 into x minus the 8 is equal to 2. Distribute -2 inside the bracket. Get -2x
minus
plus 16.
Or plus 16 is equal to 2.
Is equal to 2. We transpose the 16 over 2 minus 16. We isolate -2x. Then that -2x is giving us -14, which we divide both sides by the coefficient, which is -2. We get an x value.
It's equal to 7.
Another method. Okay. So I appreciate Ayaka, your method, because it opens our minds to the idea that, okay, so every situation has its own merits, and it's possible to have various ways of approaching the same question.
Yes.
You see, so there's this idea that you can either approach it this way, your way, Ayaka, or this way. Both ways work.
Yes.
Both ways have their own merit, and both ways they will help us to be able to attain the answer. So I appreciate,
Yes.
So a takeaway for those that are here is this idea of, one, parallel lines have equal gradients, right? Ayaka used that concept to find the equation of the straight line, which he then eventually was able to take the y value that he knew of n and substitute into it to get the x value. All right. I, with the method that I used, was also able to use the same concept of parallel lines equal gradients, and I equated the two gradients, the pk and the nr. And the fact that I have only one unknown, which was the x coordinate of n, that made it possible for me to use the equating of the two so that I can solve for the unknown. So great job, Ayak. Let's give you that clap. When are we writing, Ayak?
Writing mathematics, man. Friday.
It's still far most for you.
It's near.
It's far, man. It's far but near. For some people, they're writing tomorrow, so you can imagine why I'm saying it's far. Some people are writing paper 2 tomorrow, my guy, in other provinces. Yeah. Just check your comment section. You'll see what I'm talking about. The people who are in provinces that are writing tomorrow will tell you. They wrote paper 1 on Friday last week. They are writing paper 2 today. Tomorrow.
Whoa.
You see, Teresa there, for us is tomorrow. Okay. All right. Ayaka, Dango, my guy, determine the length of KR.
KR.
Do we have K and R as coordinates?
Yeah. Yes.
Yeah, so if we have the buoyancy, then we can definitely find the length. How do we go about it, my guy?
We'll like open the big root.
We open the what?
That big root, like
we open that big root.
Yeah,
What do I write as the subject before I open the big root?
Like write distance of KN, like D, KR.
KD, small letter D, capital letter D. How?
Small letter T.
Okay. Distance of KR is equal to, so you said the big root. Okay, there it is.
We open brackets. You say X of K.
Okay, X of K.
Minus X of R.
Minus X of R.
Squared plus.
Plus, yeah.
Y of R. Y of K. Y of K.
Y of K, thank you for the consistency. Yes, Y of K.
Minus Y of R.
Minus Y of R. Now, that's not to take away from those people that use 1 and 2, 1 and 2. That's still the same thing. You're still talking about the same thing. Okay. Then?
We substitute.
Amen. We substitute, my guy. So, X coordinate of K. What's X coordinate of K?
It's 4.
4.
Minus 8.
Minus 8. Thank you. Clean substitution. No need for sign resolving there. Okay.
Plus. Negative 6.
Negative 6.
Minus.
Minus.
Open brackets.
Okay, minus open bracket.
Negative 2.
Negative 2.
2 brackets.
Okay.
Squared.
I see what you did there. I like that. I like what you did there. Then?
It's 4 minus 8 squared plus negative 6. But 2.
Grade 10, guys. Grade 10.
5,66.
Okay, so you went ahead and you put everything into the calculator?
Yes, sir.
So what did you get as your answer?
It's 5,65, 68, 54.
Okay, let's just write the entire thing, and then we will round it off to the appropriate decimal place after we've seen it. Yeah. So it's 5,
65,
68, 68,
54,
68, 54,
249.
249. Okay, so of course we don't have an instruction here. What?
68 do you wanna get?
Okay, so it's just the 168. Sorry. Okay,
yes,
my mistake. So that means if we're rounding off, we are going to revert back to the instruction in the front cover page, which usually says round off to 2 decimal. So 2 decimal means this is where we cut off. If we say 2 decimal, we judge using the third number most. If the number is 5 or more, that means this guy, he goes up.
Gonna be 5,
yeah?
Yes, sir.
5,66 what?
Units.
Exactly, units. All right. Yeah, and remember, if they say leave your answer in third form, you would leave it in third form. But if there's no indication of third form, then we actually make sure that we round off. Yeah, and we all know what third form is, right?
Yes, sir.
What does third form mean?
Like in a simple third form, when there is a square root, like a root on the answer. Like a root of.
Seems like people in the comment section are saying that it's something else. Can we confirm 5,66? It seems like there's people that are saying it should be 5, something else. Are you guys really
they are offering it to like 1 decimal place. Or like into the nearest 10th.
You know, we're not rounding off to the nearest 10th. Hey, they must be careful, those people. They didn't say that. Okay, the answer you wrote is okay. Okay, no, they're confirming, Ayaka, that you are fine. It's correct. Mutufela is saying indeed it's correct. Okay, no, we can confirm that's the correct answer. Okay, no, it's fine. It's always good to confirm because, yeah, we can make mistakes. It's potentially possible to do such. Moving right along to 1.4. If t, k plus 1, which is the x coordinate in terms of k, and 3 minus k, which is the y coordinate in terms of k. So our coordinates here are given as expressions. Okay, grade 10 paper 2, analytical geometry, is the midpoint of PR. We are told that this is the midpoint of PR. Where is PR? P, R, so in between somewhere here, the midpoint is given by T. All right? Does that make sense?
Yes, sir.
Determine the coordinates of T and hence the value of K.
Yeah.
So what is the concept first and foremost? It is
midpoint.
So that means we must be in the know-how about the formula of a midpoint.
Oh, what no, no, I can solve it.
Yeah, what is this the midpoint of?
PR, which is
exactly, like, hey?
Yes, I think I can solve it.
Okay, let's go ahead and solve it then, because they want us first to determine the coordinates of t, and then they are saying hence, meaning after you are done, calculate the value of k using the coordinates you will have gotten of t, the midpoint.
Yes.
So how do we go about calculating the midpoint again, Mr. C?
You can use the midpoint formula, right?
Exactly, we can use the midpoint formula because we want the midpoint of who anyways? Of PR.
Of PR.
Do we have the coordinates of P and R?
Yes.
What are the coordinates of P?
It's 0, map 2.
P is 0 and 2, and then R?
R is 8 and negative 2.
8 and negative 2. So when we calculate the midpoint, okay, they said it's T most, so we can use T. Yes. And then we can open the brackets and we can basically go ahead and say what? The x coordinate of P plus the x coordinate of R.
Y divided by 2.
And
the y coordinates of P plus y coordinates of R
over 2.
Divided by 2.
Yeah. So this is the midpoint formula that we use to calculate the midpoint of a specific point that we know. We are told it's T. And so yes. Now we can substitute P, x coordinate of P.
X coordinate of P is 0.
And then R?
8. It's 8
over
2.
Y coordinate of P and R?
It's y coordinate of P, it's 2.
Okay, be careful. 2. Y coordinate of P, yes, is 2 plus?
Plus, open the bracket, then put negative 2.
Amen.
Divided by 2.
All right, so we're keeping these in the big point bracket. Then?
And x is equal to 8 divided by 2 is 4.
Okay, 8 divided by 2, that is definitely 4. Then here at the top,
it's 0.
So we have 0 over 2, which is basically 0. So our midpoint is 4 and 0. But remember, they said after getting the coordinates of t, we must, the word is hence. Hence means use what you have then found to calculate the value of k. So we're given the coordinates of t in terms of k. K plus 1 was the x coordinate. Then 3 minus k was the y coordinate. We were given these. So how do we then go about finding the value of k?
You're gonna like say 4 is equal to k plus 1.
Thank you. 4 is equal to k plus 1. Why can we say that, Ayak? Why can we say that? What you just said, why do we say that?
Because we'll be solving for the value of k.
Okay, we'll be solving for the value of k, but what gives you the authority to say 4 is equal to k plus 1?
Because 4 is the midpoint of PR, and also how can I put this?
Yeah, it's obvious, ne?
4 is the x-intercept.
It's obvious, ne?
Yes.
It's obvious, but then the thing is, you see, that's what you guys do in the classroom. You ask, why did you do that, sir? Why? So as you've said, it's obvious, but then you have to obviously explicitly say that you were given t, but you were just given the t in terms of k. Okay. Yeah, so it's fine. So you can equate this 4, which is, it's known, whereas k plus 1, it's an expression which is a representation of the 4 that you know. Hence you can equate. So what did you get? What did you get then for the value of k?
It's 3, because we're going to be transposing.
Yeah, so k is equal
4 minus 1 is equal to k.
Yeah.
Equal to 3.
Yeah.
Then we solve for the yk to see.
All right.
Correct.
It should actually also
0 is equal to
k 0. K 3 minus k is equal to 0. 0 is equal to 3 minus k. We transpose. What do we get as well?
Okay. We divide by negative on both sides.
Exactly, and we get what?
K is equal to 3.
Yeah. So obviously, it would have been very disappointing if k was not 3 as well this side. Because remember, they've used the same k. All right. Yeah. Okay, so good job, Ayak. That was very straightforward, yeah. Initially, it looked like, difficult question, but it's weak because it just requires our knowledge and our application of algebra, So don't be scared of expressions, ne?
Yes.
Let's come here to 15. Determine the equation of the perpendicular bisector. Perpendicular bisector of PR.
Perpendicular bisector. Isn't the perpendicular bisector like most e product of the perpendicular lines is equal to -1?
The product of what? What product?
Of a perpendicular lines.
Okay, you need to be specific. It can't be the product of the perpendicular lines, which was giving you -1. The product of what for those perpendicular lines?
Or the product of the gradients.
Thank you, Ayaka. Ayaka, your wording is very important. I know in your head you know what you are saying, but when you say it, and it comes out of your mouth, it must mean exactly what you are thinking. Because I know when you write down, you are going to write down what you are actually meaning, But now you need to actually make sure that what you are saying with your words, the English that is coming out of your mouth, must be sensible even to the other person. It must not just register with you when you do it, but when you are saying it, it must also be the way that you do it, you see?
Yes.
Yeah, so it's the product of the gradients gives you -1. Yeah, for perpendicular lines. So for perpendicular lines, the product of the gradients is -1. Now, that's only one idea that you are getting, Ayaka, from the statement. This part, when you've gotten this part, there's this part here that you are missing. What about bisector?
Oh.
What bi means what?
Bi means 2.
Yeah, exactly. And then sector or sect means to cut, right?
Yes, sir.
So to cut into 2. And a perpendicular bisector, it cuts midway. The line cuts midway. Midway who? Determine the equation of the perpendicular bisector of who? Of PR. So what are they basically telling you? In other words, Ayak, you in the previous question, you found the midpoint of PR.
Yes.
This is connecting this. So in other words, that perpendicular bisector passes through which point?
The midpoint.
Which is what?
T.
Yeah. Does that make sense?
Yes, sir.
Yeah. So practically speaking, let's read this thing. It says, determine the equation of the perpendicular bisector of PR in the form y is equal to mx plus c. If you want the equation of this line, what do you need? You need 2 things, Moss. When you want the equation of a straight line.
You need gradient.
So when I use, the gradient is one thing that you need. And then you also need the what?
And the coordinates. The coordinates thing.
Okay, so more practically, you need the y-intercept. But if you don't have the y-intercept, to find the y-intercept, you can use a point that passes through, or that the line passes through. Okay, which in this case is going to be T.
Yes.
Yeah.
Yes.
So, yeah. So I'm just going to say, if this is the line PR, just so that we can see this visually, perpendicular bisector is going to be a line that passes through like that. This is the line. This one. Right? This line.
Yes.
This would be our perpendicular. Perpendicular, 90 degrees angle. That's the perpendicular part. Bisector. We know obviously then that's T. So that means the midpoint. And therefore, the point that this, if it's a perpendicular bisector, it means that this line passes through T. What were the coordinates of T? We had found the coordinates of 0. T, remember? Exactly, it was 4 and 0. But the thing is, we need to find first the gradient of the new line.
Yes.
So how are we going to do that? You already mentioned a lot of things, but let's be practical now. 5 marks. We need to first find the gradient of who? Do we have the gradient of PR?
PR, yes. Oh, we didn't calculate it.
No, there was no question that asked us for such. So we are going to have to find the gradient of PR. So 0 and 2 are there. R
and 8 and
8. Negative 2.
8 and negative 2.
Yeah. So let's calculate that gradient of PR. Gradient of PR is equal to y coordinate of P minus y coordinate of R.
It's equal to 0.
Hey, it is equal to 0. That's interesting. Don't you think that's interesting, my guy? If you are saying that's the case, y coordinate of P is 2. Minus 2.
That's negative.
Can't be.
It can't be.
0.
Oh, I use the
minus
side.
Yeah, be careful with that one.
It's negative 1 over 2.
Okay,
the
so
sign.
Be careful with that sign, eh?
Yes, sir.
Then the x coordinate of P
is 0
minus 8.
Minus 8.
So we have
it's negative 1
2
over 2.
minus 2, which is 4, because that's 2 plus 2. Then of course that's 0 minus 8. That is negative 8.
Negative 8, which is about
So we get
negative 1
4
over 2.
over negative 8, which is negative 1 over
1
2.
over 2.
That is the gradient of PR. So we've gotten that one. But we don't want this one. We want that one.
Yes.
So that means the gradient of the line
PR
that we're looking for is going to be 2. Me, I'm very direct with this one because I usually say to learners that if you know that the relationship of PR and the gradient you are wanting to find will give you a product, the product will give you negative 1. There is no need to do the substitution. You can simply flip the fraction, change the sign. You want the gradient of the line that's perpendicular. So negative 1 over 2, you flip the fraction. It becomes 2 over 1. Then what do? You change the sign. It becomes positive 2. When you multiply these two, don't you get negative 1?
You get negative 1.
Yeah. So what I'm saying is that I know learners, they draw this out. Remember, you're not learning about this perpendicular concept for the first time. If you are, then it means, hey, grade 9 did not, they robbed you of grade 9 learning about the equation of straight lines and gradient. So, yeah, you flip the fraction, you change the sign. You see? So the minute you know they are perpendicular, you do that. So that is the fact that PR is perpendicular to that T, I don't know what we'll call it, but that T whatever. Okay.
Yes.
Yeah. Then we say Y is equal to 2x.
Substitute 2x plus C.
Yeah. Because that was the form that they gave us. Y is equal to mx. Now we know the gradient of the other line. It's 2, so we substitute into the equation. Y is equal to 2x plus c. Then, do we have a point? Yes.
Yes,
point T.
T.
Yeah.
Falls
Because we were told it's a perpendicular bisect. Now, let's be honest, Ayak. Some people won't see the connection between 1.5 and 1.4.
Yes.
Why? Because of this concept of perpendicular bisector. So a perpendicular bisector cuts at the midpoint of a given line.
Yes.
So these people were clever. In 1.4, they made us to find the midpoint of PR. Ne?
Yes, sir.
And then in the follow-up question, they're asking a question that relates back to 1.4. Those who don't have eyes to see, they will be blinded and then they will lose marks here. Yes, Alice, bisect means midpoint if you are talking about a line that is a perpendicular bisector to a particular line. So the equation of the perpendicular bisector of PR, they said, the perpendicular bisector of who? Of PR. So we had the line PR. The perpendicular bisector is going to be a line that cuts at the midpoint of PR. So they want the equation of this line. So as the Ayaka so beautifully explained at the beginning, for perpendicular lines, the product of the gradients is negative 1. And I say shortcut, flip the fraction of the other gradient and change the sign. Flip the fraction. Negative 1 over 2 becomes 2 over 1. You then change the sign. You see, flip the fraction, change the sign, flip the fraction, change the sign, type deal. Dump it into your brain until it becomes second nature. Then bisector means midpoint. So that means you have an actual point, which is T, which is where the line passes through. Because there's no ways that you are going to find the value of C, your y-intercept, if you don't have a point at least that the line passes through. Okay. Yeah, I hope this is very helpful. Too much. Eye-opener. So it is the midpoint. Bisector, perpendicular bisector. Yes, perpendicular bisector cuts at the midpoint of PR. And we were asked to find the midpoint of PR in the previous question, so it is T. So now we come here, we have the equation y is equal to 2x, y2, because like I said, because of perpendicular relationship, product of the gradients should give us -1. So we flip the fraction of the one line, we change the sign so that we can get the gradient of the other line. Or you can just multiply and make m the subject and get the answer. I mean, that's also fine. You are allowed to do that. Just going to take you a bit more time. Okay. Anyways, now we can substitute coordinates of t. We know most t is what? 4 and 0.
4 and 0.
X is 4, y is 0. So we go and substitute. 0 is equal to 2 into 4
times 4 plus c.
Then what is the value of c?
Equal to 8 plus
0 is equal to 8 plus c, yes?
Value of c is -8.
Amen, my guy.
And transpose
c
8.
Is equal to, very good. C is equal to -8, the equation of the line.
Then with y is equal to 2x minus 8.
And then Tina, as we finish this question, we are counting how many marks do we have in the bag already? 16. Hey! Aye. It's looking good so far.
It's going good.
It's looking good.
Getting ready.
Yeah, so that is just a taste, guys. Remember, just because I did this question doesn't mean that's the question that's going to come out in your paper. 1. 2, the concepts in analytical geometry are not limited to just these questions. There are other questions in analytical geometry, like having to deal with quadrilaterals, proving that a quadrilateral is a parallelogram, quadrilateral is a rhombus, a quadrilateral is a kite, a quadrilateral is a trapezium, using analytical methods, right? So those are other additional questions that can be asked in analytical geometry. You must be competent in being able to answer such, So this is just a, what you might call, appetizer. Appetizer. Okay. Ayaka, you've been a great sport, my guy. I don't know if you, when you might be writing other things tomorrow, and when you're busy thumping away with maths, I don't know, you're trying to distract yourself from the other subjects you are writing tomorrow or in the week. Yeah, Ayak. True story.
Yes, sir. Sir?
Did you hear what I was saying?
No, sir, I was outside,
Yeah, no, that's fine. It's good that you were outside, but I was saying that when I think like you should be studying for other things, but you are busy here with maths.
I love mathematics.
Yeah, I know you love mathematics, but the question is, do the other subjects suffer because of your love for mathematics?
I can say some, especially business studies.
Aye. So what are you writing tomorrow, Ayak?
Tomorrow, I think it's my home language, Xhosa.
Oh, okay. Home language. Then on Tuesday?
Tuesday, I'm not writing.
Wednesday?
Accounting.
Chini, you see, you should be busy with thumbing away with the numbers in accounting. It's a debit as a creditor, my guy.
I'm good in accounting.
Oh, okay.
So, yeah.
All right. I just want to get some other people to actually also participate here. But thank you so much, Mike. I really appreciate you. Chill easy. What does it look like? Chill easy is sleeping. Chill easy is sleeping. Hey, chill easy is gone.
It's already gone.
It's already gone. I wonder what. Oh, shame, man. Yeah. Life is not easy. It's tough out there.
It's tough.
Yeah, it's tough, my guy. It's tough. It's tough. Let's see. 1 plus 1 is 2, Snoko. Here's Mr. Snoko. Snoko!
Hello, sir.
Oh, there is Snoko. Guys, put it together for Snoko. Snoko, where have you been, man? We've been singing about you all this time. Where have you been?
Sir, I was busy with some other things. I left my phone on the live, so.
Oh,
Yeah.
one. You know, most we've been busy here. 1 plus 1 is 2, Snoko, eh?
Yes, sir.
Yeah. So, my guy, we are busy here. Are you coming to help participate here?
Yeah.
Oh,
I'm
okay.
writing
There we have
tomorrow.
2.1. Oh, you're writing tomorrow.
Yes.
Yeah. But we're doing paper 2. I don't know what are you writing tomorrow?
Maths paper 2.
Oh, okay, let's go, my guy. Let's go. In each of the following equations, solve for theta where theta is between 0 and 90. In other words, theta is greater than 0 but less than 90 degrees. Give your answers correct to 2 decimal places. Cos 2 theta is equal to 0.35. How do we proceed, Mr. Snoko?
So to proceed, we have to take cos 2 theta to the other side, and it will be, cos to the other side. So then it will be cos inverse. 2 theta. Then we take cos inverse. Then we open the bracket. Then we punch on our calculator.
Okay, when we punch on our calculator, what do we say on the calculator so that everybody who's here can be with you in one spirit?
We say shift, then we press the cos. Then it will show us the cos inverse, right? Then we press the number that we are given, which is 0.35. Sorry to say. Then it gives us 69.51. Then we round it off to the 2 decimal places.
So we get 2 theta is equal to, you said, what is the value?
69.512. It's an irrational number because that's it.
Okay. So we can divide by 2 both sides before we are able to.
Oh, yeah.
Yeah. That's very important. Because remember, we do not, and I just want to say to those who are viewers, we cannot from the onset divide by 2. Okay? The coefficient of the angle, we cannot divide by 2 from the beginning. We must first take the inverse. I say it's the inverse of cos, not cos inverse. Guys, when we say this thing, we say it's the inverse of cos, or we say it is arc cos. When we say it, it's either we say inverse of cos or we say arc cos. That's how we basically say this thing here. Not cos inverse. It's not appropriate to say cos inverse. It's either we say inverse of cos or we say arc cos. Then after we take that arc cos on the other side, then we can divide by 2. So I want you to tell me what is the answer that you get after taking arc cos and then dividing by 2.
It gives us 34.756 going on.
30 what?
Numbers. 4.
What is it? 30?
34.756.
34.756. Just give me the rest of the numbers after the 6.
Okay, 34244.
34244. Okay. Then of course they are saying we must give our answer correct to 2 decimal places. So that means after the second number, after the comma, 1, 2 numbers, we look at the third number, we judge the second number so that we can round it off to second decimal place. So the 6,
Yes.
since it's 5 or more, we say that the 5 then becomes what?
6.
Exactly. And then we write the angle is in degrees. So we must make sure that we have degrees.
Yes, sir.
Are we all together in the comment section? And my dear Snoko, we are together.
Yes, we are together, sir.
Oh, okay. Beautiful. Let's move on to the next one. You're going to help me with all of these. The next one says 3 cot theta minus 8. 3 cot theta minus 8 is equal to 0. Where do we
So,
start?
sir, we start by taking the negative 8 to the other side. It will give us positive 8.
There it is. 3
Yes.
cot theta is equal to 8. Good job. Step 1 accomplished. Step 2.
I think we divide it all by the 3.
Okay, divide by 3. Love that as well. Step number 2. Done and completed.
Let me punch in the
Then?
calculator and see.
Sorry?
8. Wait, sir. I'm still punching it on the calculator. It gives us, it's just 8 over 3. So then we say arc cot. Also,
Okay,
we don't have
do you-
cot, right? So cot is the reciprocal of 10. So we're gonna say 1 over 10
Awesome.
theta.
Yeah, you
And
see
theta.
there, I have to clap for you there just before you proceed. Nice one. Cot
Then
has
is
a
equal-
reciprocal. Very good.
Then it is equal to 8 over 3.
Yes.
So say from here, I'm asking for your assistance. Do we cross multiply?
Okay, very good. You see, you don't even need my assistance. You tell me what. So when you cross multiply, what happens?
I think we will get, I will say 1 times the 3, right?
Very good. 1 times 3 is equal to what?
3.
Okay, which is 3, yes. But on the other side, what's happening?
On the other side, I think it will become, you see here now, I'm having a bit confusion.
8 times tan of theta.
Theta.
Are you? Do you see? You said you are the one that said, don't we cross multiply? Say, I'm like, beautiful. So 3 joins 1, multiply. Tan theta joins 8, multiply. You see, but 8 becomes the coefficient. Tan basically becomes the variable, if you'd like to call it that. So now we have what? 8 tan theta is equal to 3.
Yes. So why don't we write it in a proper way and say
That's
8
fine.
tan
Tell me.
theta?
Very good. 8 tan theta is equal to 3. Remember, equal is the same thing, equal this way. That's fine. I'm very happy. I'm very pleased that you would say that. Then
8 tan theta is equal to 3. We divide by 3. We divide by 8, I mean to say.
Yeah. I was like, you're failing me now. But very good. You fixed yourself immediately. We divide by the coefficient of tan.
Yes, the 8 and 8 cancel. Tan theta is left and 3 over 8.
Very good. Then
So then we say theta is equals to inverse of tan.
yes, inverse of tan. You see, you're even saying things right. Hey, this guy.
Then we say 3 over 8.
3 over 8. Yes. Very good.
Then when we punch it on the calculator, it gives us 20,556,04522.
20,5560, but you give me now the rounded off value to 2 decimal places.
It's gonna be 20,56.
20,56. Then we make sure we have the degrees there. Okay.
Degrees.
Good job.
Yeah, that's our final
Good
answer.
job. All right. Now, I want. What's your name? Let me not call you Snorkel because now everybody's gonna think you are Snorkel.
My name is Austin.
Austin. Okay. Listen. Do you see here? You said cot theta is equal to 8/3.
Yes, sir.
Then cot.
Sir.
So it's having a bad network.
Yes.
Like, I think I was going to tell you that like cot and tan are made up with one thing, like being like lanto yokubana it's thina lanto ka sokathoya kodwa yabo.
Yeah.
So like ucot izoba must kuthiwa adjacent over ithina adjacent over opposite ne. Then ku-cot izothi opposite over adjacent like lanto.
Oh,
Sorry guys. Yeah. I think Ayaka got my point there. That here at this stage, if cot theta is equal to 8/3, right? You know that cot is actually adjacent over opposite. The reciprocal of cot is tan, which means you can flip this fraction. From this stage, you could have just said tan theta is equal to 3/8. All you do is you flip this guy and you write 3/8 and change cot to tan. That complements, because you see, you eventually got there, but after how many steps?
So many steps.
Yeah. So what I'm saying is that all teachers that are marking, they know that you know the relationship that exists between cot and tan, that it's the reciprocal. So, I mean, it's good. I mean, maybe even after this stage of saying cot 1/tan is equal to 8/3, you can then write and say tan theta is equal to 3/8. You flip, like you flip both.
Yeah.
Tan theta at the top, 1 at the bottom, 3 at the top, 8 at the bottom. Then it's, you see, you get to this step and then you solve.
Yes, sir.
Yeah. Otherwise, I love the algebra because with your cross multiplication, step by step, you were able to show Austin is very good at algebra.
Yeah.
Thank you, sir.
Okay. All right. Let's come here. 2.2. Without the use of a calculator, calculate cos squared 45 minus sin theta.
So, sir, I'm sure they're saying without the use of calculator.
Yes.
In this case, we can use a calculator, but in a smart way.
I love that. Who said that to you? Because I almost feel like a teacher is coming out of you. The way, what you are saying is something that a teacher would say.
Yes, our teacher told us this.
Use a calculator, but in a smart way. But you guys understand as well that without the use of a calculator, it's more of like it's telling you must show the steps.
Yes.
You can't just put this in a calculator and then bam, the answer.
Yes.
Yeah.
I got these are special angles.
Exactly, very good. Special angles. So we must then make sure that our ratios, they reflect what is usually in the special angles. So 2 triangles are very important for that. The 1, 1, root 2 triangle that is isosceles right angle, which has 45, 45, and 90. That is the first one you must be able to use when there's 45 degrees, because if you decide to utilize the substitution of the calculator, it will give you slightly different, it's the same value, but it's just that it's a rationalized value. And in grade 10, we don't want to be going there just yet because of limitations imposed on you for now. Okay. Then there is the 30-60. Ne? 60 there, 30 here with the 90. Then you have 2, 1, root 3. 60 degrees always opposite root 3. 30 is always opposite 1. And then 90 is always opposite 2.
Yes, sir.
Yeah, then when you come to this specifically, you must utilize these ratios that you read from these special triangles and substitute them initially there. So I like that you said you use the calculator, but in a smart way. But please take into consideration, okay? Take into consideration that the 45-45 degree triangle is 1, 1, root 2. Then the 30-61, okay, is very important as well. Okay. Hey, who is this person? Maite has been saying accept. Let me just give this person a chance, because I feel like, you know, when they say TikTok harassment. Hello.
Hello.
You've been saying please accept. You're spamming my comment section. Hello. Yes. So how can we help you, or how can you help us?
Okay, no, it's fine. Can you please continue this question, then I'll continue. Like, I'm listening.
Can you continue this question?
After I'm writing tomorrow paper 2 and I don't understand anything.
What don't you understand? This question specifically.
Yeah.
All right. So, Austin, what were you going to do? What were you going to do initially?
So it says cos 45. What I was gonna start by saying cos 45. It's gonna give me on the calculator. It's gonna give me root of 2 over 2, right? So then, since it's not this value on the triangle, I'm gonna say 1 over root 2.
Thank you. You see, I think like I almost feel like you were definitely supposed to be here. So thank you for saying that. I really appreciate that you said that explicitly. And it's very important what Austin said. Austin said when he goes to the calculator and types in cos 45, it gives him root 2 over 2. That value, guys, is the one that will get you penalized, because it is not a reflection of the value that is in the special angle triangle. They want this substitution. So, for instance, cos squared 45, this is the same thing as cos 45 degrees squared. So what you would do is you would have to come to the triangle. You know the definition of cos. Cos, remember SOHCAHTOA, ka, adjacent over hypotenuse. So we go to 45 and we're like, well, the adjacent side is 1. Then the hypotenuse, root 2. Then you square that.
Root 2.
Yeah, because it's root 2, the hypotenuse. The adjacent side is 1. So you get a mark for this correct substitution of the ratio as represented in the special angle triangle, not for the calculator value. Okay. Hence, I
Yes.
liked what Austin said. You use the calculator in a smart way, but you must know these two triangles so that you can utilize the values that basically should come from the triangles.
Yes, sir.
Okay.
So wait,
Maina.
teacher, are they gonna give
Yes.
us these two triangles? Okay,
They
then.
don't give them to you. You should know them. You should know them. You're saying, Kanti, what's been happening?
So wait, how's the question? Like, give me an example of how, like,
There is the question. Without the use of a
they didn't teach us
calculator-
special angles.
Okay, all right. So we are now looking at special angles. Special angles, all right, you have 45, 30, 60, which we regard as special angles. So there's these triangles that you basically use whenever you are faced with a special angle expression that has 45 degrees, as you can see there, and 30 degrees, as you can see there. So the two triangles, the first one is your 45 and 45 degree angle triangle. All right. So all you do is when you are asked for cos of 45, as you are asked here, but there's a square here. So what I usually tend to tell people is that please take the square outside the bracket for the ratio so that you can see the single ratio inside the bracket on its own. So if there was an exponent 4, I would take the 4 out and then isolate the ratio inside the bracket with the angle. Because what you want to do is use the triangle so that you can express cos 45 in terms of the sides that you have there.
Okay.
Are you following? So since you
Yes.
know the definition of cos is adjacent over hypotenuse, you come there. There's the 45 degree angle. The adjacent side of 45, this 45, is 1. Just like the adjacent side of this 45 is 1. Then the hypotenuse side of this triangle. Remember, the hypotenuse is always opposite your 90 degree angle. So this box means 90, right angle. So this is your hypotenuse, it's root 2. So that's why we say cos 45 is 1 over root 2. Then we do what? We square it. All right? You get a mark for that substitution from the triangle. This triangle. Will they give it to you? No, you must know it.
No. Yes, sir. That's why I was saying we can use a calculator in a smart way.
So if the calculator answer does not resonate with this value that you are getting from the triangle, then you know you must reject that value in the calculator and accept the one that the triangle is giving you. So I get you when you are saying, Austin, you must use your calculator in a smart way. Then we come to 30, sine of 30. That's isolated already, there's no exponent. Okay, Thema, if you switch it around, problem. And when you mean switch it around, you mean if you write root 2 over 1. I don't understand what Thema is saying there in the comment section. Switch it around in what sense? Yeah, if you say root 2 over 1, then it's wrong, Thema. Sorry, unfortunately. If you say root 2 over 1, that's wrong. You get penalized. Okay? You've identified the wrong ratio. Then sine 30, we are no longer looking at the 45 degree angle triangle. We are looking at the 30-60. Okay? Yeah, I can go with them. What do you mean, how is it wrong? That's like me asking you to walk on your head. upside down. Would that be right? Haibo. Okay, guys, the numerator can never be the denominator, and the denominator can never be the numerator. All right?
Yes.
So remember, cos has a definition which is adjacent over hypotenuse. You come to this 45 degree, and then you say, what is the definition of cos adjacent? The word adjacent means next to. So the side that is next to 45 degrees is this one. We disqualify root 2 as a side next to because root 2 is a hypotenuse, because 90 degrees is always opposite the hypotenuse. Okay, so that's very important. So if you write root 2 over 1, then that's the wrong ratio, so you can't be correct. Okay, sine 30, we go to 30 degrees. Okay, just going to write this triangle a bit bigger because I feel like you can't see, most of you. Root 3, 1, 2, you have 60, that's 90. So sine 30, here's 30 degrees. And the definition of sine is so, opposite over hypotenuse. So what's opposite this 30 degrees?
Opposite, it's the 60 degree, or the 1.
Yes, it's the 1. So we are going to say 1 over. Where's the hypotenuse side? Exactly, over 2. Done. You get a mark here for this substitution. I believe the calculator answer is the same, Austin?
Yeah, let me verify, sir.
Yes.
Yeah, I believe it is. If you say sine 30, you'll get 1 over 2.
Yes, it's 1 over
Yes,
2.
yes, it's the same. On the calculator, sine 30 is the same.
Exactly. So for that one, you are safe because it
Yes.
resonates with the calculator answer. You see, it resonates with the triangle reading.
So then,
Okay, using the definition. Then from here, straightforward, guys. Half 1 over root 2, you apply the square at the top, you get 1. You apply the square at the bottom, the square root of the square is 2. So half minus half, guys, is 0.
0.
0. Final answer.
You get a mark for that one. Okay, so all that is required is just the substitution from the triangles and then the final answer. Now I just want to bring to your attention, guys, that without the triangles, there are other special angles that don't need a triangle. 0, 90, 180, 270, and 360. Okay, and then obviously these angles, all you'd have to do, if let's say you get something that says sine 180, just grab your calculator. Your calculator will give you the value that is actually appropriate. So these ones, you can just simply use your calculator to get their values. They say sine 0 is 0. Sine 90 is positive 1. What I'm saying is your calculator will give you the actual value, right? That is appropriate for the situation. It's only 45, 30, and 60 that have specific special triangles that you need to read or extract your values from so that you can substitute. Okay, I hope we are clear, guys. Is it clear enough?
Yeah.
Sorry?
Yes.
I think our girl is saying no.
No, it's clear.
Sorry?
It's clear, you can continue.
It's clear. Oh, okay. Sorry, I thought you were saying no. Okay, all right. 2.3. Lena's most favorite question in the world. If 2 sine theta minus 1 is equal to 0 and theta is greater than 0 but less than 90, with the aid of a diagram, without the use of a calculator, determine the value of tan theta. And then the second question says 1 over cosec theta minus 2. So how do we step by step answer questions like this? Very nice questions.
We start by solving for theta.
We start by what?
Finding the value of theta.
Okay, no. We don't start by finding the value of theta. No. Okay, let's retry again. What do we start off by doing?
Sir, can you please shift your camera so yeah, it's fine.
Okay, so this equation here, we must take that equation and isolate the trig ratio. That's where we start. Take the equation, make the trig ratio the subject of the equation.
Yes,
So sine theta, we need to make it the subject.
Okay. Sine theta is equal to 1 over 2, yeah?
Yeah, so let me just write it out first. 2 sine theta minus 1 is equal to 0, right?
You transpose -1.
Okay. Transpose the -1 to be +1.
Yes, then you divide by 2 both sides.
Thank you. We divide by 2 both sides. And what do we get?
And sine theta is equal to 1 over 2.
All right. Then let's stop right here for a moment. Let's stop right here for a moment.
Yes,
let's stop right here for a moment. We'll proceed. I just want us to take this in first. So what's important first is to look at that equation. We don't press shift arc, guys. No. We are not solving for theta.
We're gonna be like hypotenuse and the opposite.
Yeah. I see someone in the comment section saying, you know, we take arc sine on the other side. No. Please, guys, look at the question. Okay. In questions like 2.1.1 and 2.1.2, that is where we solve for theta. Ne? And yes, at some point, we use the calculator. But here, we are asked, please guys, take note. They are saying if 2 sine theta minus 1 is equal to 0 and theta is between 0 and 90, they are saying with the aid of a diagram. So this is that cast thingy that Colin Fortin is saying in the comment section we should be doing. That cast thingy. And I love how people say thingies. It's that cast thingy where you have to draw a sketch in a particular quadrant, all right? But in order to do that, you need to first start here, okay? So these are the cast diagram type questions with the aid of a diagram without the use of a calculator. So this is step 1. Isolate the trig ratio. Then there are 2 things we can get from the isolation of the trig ratio. I think Ayaka wants to help us out there. So what were you going to say?
I will be like saying, Tishala, singazoba i-triangle yethu, and we know we hypotenuse and
before the drawing.
Yes.
What can we get from the fact that sine theta is equal to half? What can we learn from this? Okay, firstly, half, is it a positive number or a negative number?
Positive.
Okay, this is a positive number, guys. So that means sine is positive. Are you with me?
Yes.
Sine theta is equal to half. Sine is a positive because of the fact that half is positive. Remember, sine theta is equated with half. Half is a representation of sine theta. Sine theta is a representation of half. So we are saying sine is what? Positive, because there's a positive ratio on the right hand side. Are you with me? If there was a negative number this side, we're going to say sine is negative.
Negative.
But because there is a positive ratio, we are saying sine is positive. Are we together? Then
Yes,
the
sir.
second thing, so that's the first thing. Second, what is the definition of sine?
Sine equals to opposite
Opposite
over hypotenuse.
Thank you. Wow, what a beautiful choir you guys are. I think you guys could sing. I'm telling you. I think I'm gonna start a Maths as a Game choir. It's so how like in unison. You guys came together so beautifully. Okay. So two things. Sine is positive. That's the first thing. Second thing, the definition of sine. Opposite over hypotenuse. Some people even say y over r if we are looking in terms of the Cartesian plane. All right? Y is the value of the opposite, r is the value of the hypotenuse. So these are two things you need to come to the conclusion about. So if you look at this ratio, that means y at the top is what? 1. R at the bottom is 2.
2.
Okay? And I need you to lock in here, guys, because that's why when Austin said, we are going to solve for theta, I went crazy because I was like, what? You can't be solving for theta. What we want here is to isolate the trig ratio so that we can get an understanding as to what sign is the trig ratio 1. 2, what is the current definition of the trig ratio, and what can we then represent 1 and 2 as on the Cartesian plane? Because we are going to sketch on the Cartesian plane, and we need to have a good understanding as to the definition of sine, and also in terms of y, x, and r, what do we have here in the fraction? Are we together? Or am I losing?
Yes, sir.
Are we sure, guys?
I say now you're losing me. So
if I'm losing you, my question, did you do these questions at school? Did we do them? Where am I losing you, Austin? Austin, where am I losing you? So at this part, isolating the trig ratio, do you understand that we isolate the trig ratio?
yes, I'm fine.
Okay. Then I'm saying from this information, you should make two important conclusions. One, sine, is it positive or negative? That's what we are asking. The trig ratio that is isolated, is it positive or negative? So what did we say?
In this case, it is positive.
Yeah, it is positive. Why did we say it's positive?
Because half is positive.
Thank you, because half is a positive number. Not 0.5, guys, is a positive number. Okay? Okay?
Yes, sir.
Then
Wait.
Yes.
Hey. So when
Yes.
do you know when to use special angles and when to use this one?
My dear, I said 45, 30 question without the use of a calculator. Calculate cos squared 45 minus sine 30. Special angles, we said 45, 60, 30.
Okay.
Those triangles that we drew, these guys, these ones, they are used when there's 30, 60, 45. That's when you know you need to use special angle.
Okay. Thank you.
This question here is one that requires us to do what? To basically sketch a diagram in a particular quadrant so that we can answer these questions that are here. We can't answer these questions until we have a diagram in a specific quadrant. So let's come back here. So I said you must first isolate the trig ratio. I still stand by the first step. Isolate the trig ratio.
So, sir,
You
can
don't
I
solve
ask
for theta. Yes, ask.
if we solve for theta and substitute on the equations, our answers are going to be wrong.
No. The things you see, this part is where you are going to fall short without the use of a calculator, and therefore, Austin, because you will solve and get
Yes, sir.
decimals, then I know we're not. Okay, so we don't do that. So we've just covered the first step. Now let's come here. Once we've done this, then we can come here. There is this thing here. This is called our restriction. Theta greater than 0 but less than 90. What does this mean?
It means the value of theta that we are going to get, it has to be greater than 0 but less than 90 degrees.
Greater than 0 but less than 90. So, you see now I'm going to come here. Let's go to our quadrants. 0, 90, 180, 270. Back here we have 360. We are going to now sketch and draw, my guy. And this is what we are going to do. Firstly, if we look at 0 to 90, which quadrant are we referring to when we say 0 to 90? Which quadrant is that? Is
The
it
first
the first quadrant, second quadrant, third quadrant, fourth quadrant?
The first quadrant.
Yes, it is the first quadrant. So I'm going to put a tick there on the first quadrant. Are we together? Then
Yes,
I'm
sir.
going to come back here. Do you remember I said sine is what? Positive. Do you remember that?
Yes, sir.
Now my question is, where is sine positive? In which quadrant?
Oh, I don't have my notes.
So that is where this thing comes into the picture. ASTC, the cast diagram. Do you still remember AST? See? All students take coffee or chemistry.
Yeah. Yes.
All. Meaning all the
Students.
trig ratios, sine, cos, and tan, and its reciprocals are positive in the first quadrant. All. Here, who is positive?
Sin.
Yes. Sine is positive here. Here, who is positive?
10.
Exactly.
10 or 10.
And then here, who is positive?
Cause.
Cos.
Exactly, cos is positive here. So all students take chemistry, coffee. Hey, I don't want to mention all the others, but like there's many things students are taking nowadays. You know, it's very sad. I don't want to even talk about other things. Yeah. Anyways, so if we have this, we must remember as well that in this quadrant, if sine is positive, what about cos and sine here?
They will be negative.
Exactly. Cos and tan will be negative in this quadrant. What about here? Tan is positive. Who is negative?
Cause
Sin
and
and
sin.
cos.
Cos and?
Sin.
Sin.
Cos and sine, yes. Here, who? If cos is positive, who is negative?
Sin and tan.
Ten.
Tan
Ten and
and?
sin. Sin.
Thank you. All right. You guys love sin, don't you? Yeah. Call it sine, guys. Sin. Yeah. Anyways.
Sin.
Yes, not cyan bougie, but like cyan. Yeah, not cyan. Yeah, not cyan. Please. Not... Okay, so if now we ask ourselves, where is sign positive? Which quadrants are we going to identify?
On the second.
The second one.
Sir,
The second,
on the first
yes,
and second.
and the first. Very good.
Yes.
Now, guys, please take note. The restriction made me tick the first quadrant. Ne? 0 to 9.
Yes.
Then sign is positive made me tick the first quadrant again and the second quadrant for the first time. Where are my ticks overlapping? In the first quadrant. All right. The overlap of the ticks. When I ticked for the restrictions, it was first quadrant. When I ticked for where sign is positive, it was first and second. Then I go to the overlap because that will help me know in which quadrant I need to sketch my angle theta and where I need to complete my right angle triangle.
Also said the whole quadrant thing will help us sketch our triangle.
Amen. 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 Hallelujah. Amen. Okay, I need Maite to also clarify if she understands.
Yes, I understand.
Do you want to help me pronounce your name properly?
No, it's correct. It's correct.
Oh, okay. Because I don't want to be butchering your name as well, you know.
No, it's correct.
Okay. So are we fine?
Yes.
So guys, please, isolating the trig ratio, the intention is to first figure out what is the sign of the trig ratio based on its value on the right. Yeah, I don't know what's wrong with this. I'm so irritated by this Ashley character. This Ashley character is everywhere. Doesn't matter which live you are doing. Ashley character is everywhere. You block, and then she finds a way to get back into your life some other way. Yeah, I think some people are crazy, you know. But I believe this person is not what he claims. It's a scammer, this one. It's a big time scam. Yeah, so now you will be excited to, you know, but you are sending yourself down a tube of craziness. Sorry guys, let me just scammers, big time scam. Just want to mute this person and block him as well. But I know she comes back with another account. Okay. Anyways, yeah. So the intention of isolating is so that we can get an idea as to whether the trig ratio is positive or negative. There we have, you see, that's what I was saying. Blog calls the friends. They are together. I'm sorry guys. These people they always are here. I don't know why. It's like they're on a mission. I don't want to be racist or funny, but like I always envision either people in India sitting in a room and they are looking for people to potentially scam, and then they come and it goes crazy. So yeah, scammers, they come in various ways. All right, anyways, so let's check now. If the trig ratio is isolated, we know that half is positive, therefore sign is positive. Then we can judge where is sign positive in which quadrant. We tick the relevant quadrants. Then our restriction will also give us places to tick. Yes.
So say, what if our sign was negative?
Then we would say, where is sign negative? You tick those
Yeah, I agree
quadrants.
on this other quadrant. How are we gonna know that it is over? What did you say?
It's
Overlapping.
overlapping. Yeah, it's
You're gonna
overlapping.
look at the zero,
In
like it will
in
tell you that it's greater than what.
Oh yeah, I understand. Thank you.
yeah. So you also check the restriction, right? And that's where
Yes.
basically, yeah. But obviously, if they had said sign is negative, it would be negative in the third and the fourth. And then this restriction wouldn't be enough to help us to be able to know where we need to sketch. Okay.
Yeah,
So
that's
that's
what I
the
was asking.
yeah. So they wouldn't give us a problem like that. They would make sure they give us a problem where they know there's going to be an overlap. Okay. Yeah. And the overlap can only be one overlap at a time, which will basically help us. Okay. So I hope we're clear there. So now that we have the triangle, did you see I drew a terminal arm? And then after drawing the terminal arm, I make sure that I actually complete my right angle triangle. Okay. Then let's come here. Now I can include, all right? Sine theta is what, guys? Opposite over
Hypotenuse.
Opposite over hypotenuse.
opposite over hypotenuse. So I come here and I say opposite, that's y is equal to 1. Hypotenuse, r is equal to 2. Make sense?
Yes, then we can find out.
Then I need to find x, which I don't have at the moment, but I can find
We
x
can
using
use-
what?
Theorem of Pythagoras.
Exactly. All right. Then you can
You
use,
can
yeah, you can only use the theorem of Pythagoras.
Let's see.
Okay. Yeah. So let's use then the theorem of Pythagoras and get the value of x. So this is what we do. We say
so I can't use
r
10.
squared. We can't use any trig ratio here.
So, sir,
Find
wait.
the-
Can I ask?
Yes, please ask. Yeah.
Aren't we adding only if the what we are finding is the hypotenuse?
No. The hypotenuse we already have.
Yeah, I mean, when we are doing the theorem of Pythagoras, isn't it supposed to be r squared x2 minus y2? Because we are
Theorem of
not looking
Pythagoras is
for.
r squared. Remember, theorem of Pythagoras is used for right angle triangles. It means the square of the hypotenuse side is equal to the sum of the square of the other two sides.
Okay, so let's continue. I
Yeah. So this
understand.
is the square of the hypotenuse side. Okay. Then it's equal to what? The sum. That's plus the sum of the square of the other two sides. Make sense?
Yes, it does, definitely.
Yeah. So yeah, that's how we go about it. Okay, so I'm going to write there r squared, 2 squared, okay, x squared, that's what I'm looking for, y squared, 1 squared.
Okay.
Then we get 4 is equal to x squared plus 1.
Plus 1. Then
We transpose the 1.
to the other side. Yeah, that's what I was asking.
We get 3. And then we take the
Then-
square root.
Then we leave it in set form.
We write x squared, we take the square root and we write plus minus because there are 2 possible answers, one positive and one negative. So if we write our final answer, we can write x is equal to plus minus root 3. But if we look on this side of the x-axis, what should the value of x be?
Positive
Exactly. So we conclude and
3,
say x
positive
is equal
3.
to positive root 3. Okay. So then we write there positive root 3. Does that make sense, guys?
Yes, sir.
Yeah.
Yes, yes, sir.
Yo. So then we now have all our sides. R is equal to 2, y is equal to 1, x is equal to root 3. We have theta, 90, and I usually say to my learners that please write the third angle there, 90 minus theta. If you add all the angles together, 90 plus theta, and then you subtract, you say 180 minus the theta minus the 90, sum of angles in a triangle, you get the third angle in terms of theta. It's 90 minus theta. Just so that in this triangle, you have all the sides and all the angles. I usually say that it's so nice to have all the sides and all the angles because you can never anticipate the questions that may come.
Yes.
Yeah.
So, sir,
Okay. Yes.
sir, since they give us 1 hour to write, are you gonna get the time to do all this?
Yeah, you're going to get the time to do all of this. The thing is, you see, the thing is that the only reason why I'm taking time is because I'm having to explain to you what I'm doing. Remember,
Okay.
the steps here are very easy. You take the trig ratio, you isolate it. It shouldn't take you long because in term 1, you did literal equations, how to make something the subject of the equation. So making sine theta the subject, it shouldn't be something that will take you long. Then from there, you get sine theta is equal to half. There are two things from there. Sine is positive. You go to your quadrant and you ask, where is sine positive? If you know your SOHCAHTOA star, if you know your cast diagram and everything, you'll be able to just draw a rough Cartesian plane and then tick the quadrants where sine is positive. Okay? Then you tick, you go to your restriction. Then you ask, what does this mean? Theta is between 0 and 90. Where is that? You tick. Then you come to your right angle triangle. You sketch. You then use the ratio to then say, okay, if it's sine theta, there it is, wherever it is in whatever quadrant, opposite over hypotenuse. Then you use Pythagoras. You solve. You get the missing side. Okay? Does that make sense?
Yes.
Then after doing so, you can come down and go and answer the actual questions because they wanted, if you remember, us to calculate the value of tan theta. So you need the diagram to be able to find what tan of theta is. So tan of theta, you are going to go to that diagram. Tan theta, go to the diagram. You go and read from the diagram what tan is of theta. What's the definition? TOA. Okay. So what is that?
Over adjacent.
Which is what, according to this diagram? Yes, theta.
1 over root 3.
1 over root 3. Done. This is the value of tan theta.
Clock it.
Man, I think we can be animals as well. Makes animal sounds.
Sir,
Yes.
but even if I do it the way of solving for theta, I'm still gonna get to the same answer.
Sorry?
If I'm doing it, while I'm doing it, I start by solving for theta.
Yeah, but the thing is, you are going to get penalized. You are not going to get your marks because you did not follow the instruction. The thing is, if you do that, you are not going to get your marks, my guy. because they said without using a calculator with the aid. Here's the diagram that they want. If they don't see this, you are going to lose marks. They're going to penalize you. You're not going to get your marks. I can just tell you that. Off the bat. Yes. Yes.
So
Yes.
like when you get your question paper, you must also write this diagram, draw this diagram for extra, like for a mark.
The diagram must be there because what did they say? With the aid of a diagram. So this one is the one that they want. With all sides completed, with all angles. So after Pythagoras, you'll have all the sides.
With the aid of, okay. And
Yeah. Gee, Matoda, didn't you see the English? With the aid of a diagram. Do you guys think it was first aid or something?
No, sir.
Hey, guys are in. Hi, yeah. Hey, what's happening? Hey, it's dying. Maite.
Yes.
Maite, I hope you don't have TB there. Hey.
Yes, I'm sick.
Hey, my guy, it seems like you've been sick for a long time. This is not a series of sickness.
Yes.
How, Maite? Yeah, you see, people are even concerned in the comment section. I'm also concerned now. I mean, it is no joke. Hey, that cough is very. Hey.
Yes, sir. So wait, so if you want to calculate, like, you see, like, x, then you're gonna know that you have to use Pythagoras. Also, like, let's say they didn't give you r, then you're gonna use Pythagoras. Okay.
Yeah,
Okay.
because there's always going to be this side or this value that's going to be missing. Remember, your trig ratio, the one that you've isolated, will give you 2 of the sides, but 1 will always be missing. So Pythagoras you will always have to use Pythagoras to find.
Okay.
Okay.
Yeah. Hopefully that's clear for us.
Yeah, we understand.
Understood.
Okay, so we got one value, tan theta. Then
Yes.
that was not the only thing they asked. They also asked for 1 over cosec theta minus 2. So we say 1 over cosec theta minus 2. Then we go and read what cosec is from the diagram. Cosec is the reciprocal of sine. So we are not going to say opposite over hypotenuse. Rather, we're going to say hypotenuse over
opposite.
Amen, because that's the reciprocal. So that means 2 over 1. So the substitution, we have the 1, which is that one. Cosec is 2 over 1. But that's the same thing. 2 over 1 is just 2, right? That's what 2 over 1 is. Okay. So if you think about it practically, we're saying 1 divided. This line means divide. 1 divided by 2 over 1, right?
2 over 1.
That's
It's
what
the same
this
as 1
is.
divided by 2.
Yeah, 1 divided by 2 over 1. Then we have that minus 2 there. But we know that we can change divide to multiply. Then what happens to the fraction? KCF? We
Flips.
Change, flip. Then 1 times half. Half minus 2. Then you can grab your calculator and just write the answer, which will be negative 3 over 2. Your calculator will just help you there. Half minus 2 will give you negative 3 over 2. Okay. This is the value. Negative 3 over 2 is the value of 1 over cosec theta minus 2. You substitute.
Okay.
You simplify and solve. Substitute, simplify, solve. Substitute. Okay, I'll tell you this. There's marks here, marks here, marks there, and then of course the rest of the marks there. So
wait,
isolating. Yes.
So can you please wait like that so I can take a screenshot so tomorrow when I revise I can remember.
Hey, this girl is on fire.
Yeah. Yes, it's fine. Thank you.
Okay. Then, of course, this was the substitution get, because we need to get tan theta. So the value is 1 over root 3. Then we needed to get the value of 1 over cosec theta minus 2. We substitute, we get the value at the end.
Okay, I took a screenshot. Thank you.
Okay, so yeah, man, yeah, these are the questions that we can potentially get in trigonometry. But like I said, these are not limited, guys. This is not, I want to repeat, I want to put a disclaimer, because if people are here and they're like, yeah, it says doing the paper, the one we are writing tomorrow, good luck, but this is not the paper. This is just, like I said, it's just revising a particular paper so that we can get familiarized with some of the concepts. But they are not limited to just these. These are not the only questions in the world that you can ever get asked. So that's why you should have been practicing, you should have been, not just now that I'm here. You should have been.
Yo, TDA. Yo.
Hello. Hello. Woo. Woo. Maite. Maitalas. Okay, let's read. Let's complete, because there's the statements that we need to know. Complete the following statement. The adjacent angles on a straight line are. Let's see if people know what they should know. The adjacent angles on a straight line are. Let it rip in the comment section, guys. The adjacent angles on a straight line are. Oh, and by the way, guys, we've been live now for quite a few hours. Those that can send a rose or a gift there and there, please do send if you can. But if you can't, it's no problem. I'm just trying to really, like, I know there's parents that are here. Some parents are just here, they want to give moral support to their kids. Because some kids, they get their parents to actually like chill here in the live, and have all sorts of fun with them. Thank you, Puti. Thank you so much. Really appreciate it. So guys, the adjacent angles on a straight line, I see in the comment section, the adjacent angles on a straight line are, I Lusanda. Sis. Lusanda, how can you say 90? What is this? Adjacent angles on a straight line are 90 degrees. Hi guys. Okay. So Maite, do you know the adjacent angles on a straight line?
Supplementary.
180
They
degrees. And the supplementary.
Okay. Supplementary. The word we are looking for is that fancy word, supplementary. That's what we are looking for, so that the people that are marking us, they know we are serious, Tina. We are serious. Supplementary. Yeah. That supplementary means what?
They add up to 180 degrees.
Exactly. The word itself, supplementary, means add up to 180. Those who are saying the adjacent angles on a straight line are 90 degrees. No, guys. Angles on a straight line, adjacent angles. The word adjacent means next to each other. So the typical example that I can give, if you have a straight line like this, you have B, there's 1 and 2. Angle B1 plus angle B2. They are angles that are next to each other. They are adjacent. They lie on a straight line. So that's why we say adjacent angles on a straight line are what?
Supplementary.
Yeah, they're supplementary. They add up to 180 in other words. Okay. And we know mostly angles on a straight line. STR line is what we usually use as a reason to support that. Anyways, let's go down. In the diagram below, can someone read this for me? Even if it's you.
Okay. In the diagram below, MRX, okay, the angle R equals to 5x minus 40 degrees. E angle RC equals to so is this a letter? Is this B a letter part of the
It's a
sum?
letter. It's B.
Okay, equals to B. And then R angle XC equals to A. M angle CX equals to 2x. And E angle XC equals to 100 degrees.
Yeah, all right. Thank you so much for that supreme reading there. You see, you got like supreme reading skills there, Maid.
Thank you.
So there we have it. Let's just look at what was identified as the angles and reconcile what we have here to check if it is in the diagram and if it is sensible according to what they said. MRX, angle MRX. Let's move with the letters. MR, the mid letter with a caret. Must the caret, CARET, signifies the angle that we are talking about. Middle. MR, angle MR. There we have it. It's there. X. Makes sense? Okay. The
Yes, sir.
expression of the angle, 5x minus 40 degrees. Then, angle ERC. E, where are you, E? There, ERC. Indeed, the arms, the vertex, the angle. B. Makes sense? It's there.
Yes, sir.
Angle RXC. RXC. The angle A is there. Angle MCX. 2x. It's there. And angle EXC. 100. There it is. It really is indeed what has been stated in the statement. What is in the statement is fully expressed in the diagram. Let's look at the questions then. Use the diagram above to determine with reasons the following. Who? A. Maite. Any thoughts?
Yes, sir. Let me
Look at
think.
A. Look at
Sir,
A, Maite.
we could
Where
use
is A, Maite? Just wait,
It's in
just
the
wait,
inside of the
Austin.
triangle.
And then
It's in the
what is
inside
it
of the
next to?
triangle.
What is it next
It's
to?
you can say it's a straight line. So you can say A
Ooh.
equals to 80.
Reason.
Supplementary angles add up to 180. 100 plus
Okay,
80 in the inside equals to 180.
All right. I agree with the logic that you have expressed, that A is equal to 80. Right? I agree with the logic that you have expressed. The reason, though, is something that needs to be very, very specific. All right. Maybe in grade 10, I don't know, some teachers are very okay with the reasoning that is a bit loose. But me, yeah, I'm very strict with the reason, guys. So if you look at Lusanda, what is typed there, just the recent comment. That is the reason you must write.
Oh, angles of straight line. Oh.
Amen. Amen. Hallelujah. Hallelujah. Hallelujah.
Okay.
Hallelujah. So we say A is equal to, you can go ahead and say A is equal to 80 degrees, like straight up. And then you say angles on a STR line. The symbol for angles on a STR for short, just for straight line, and then STR line. You close brackets, so you have your statement and your reason. I have no problem with those that would go ahead and actually say, instead of this, just go ahead and say A plus 100 degrees is equal to 180 degrees. Angles on a straight line. Then they solve. That's also fine. But even if you do this or that, you still get full marks. All right?
Yes.
Because this one is intuitive in your head. And then this one is just you showing you're working out. That's also fine. So when you get an answer, you go and update your diagram. It's like if you have a phone and you don't update your phone, then its functionality will be left behind. Likewise, if you don't update your diagram with the new information that you got, you might find that the next question will be compromised. Okay, so I have advised pencil, but by the time you hand in your paper, it must be so dirty that even the teacher is like, "Hi, bo, Maite, what is wrong with you? What happened with you?" You're like, "Sir, I was busy. I was so busy." You know, like I was so busy, and I said, like, I mean, yeah. Okay, let's move down now. Are we happy with our first answer, Maite?
Yes, sir. Yes, sir.
And are we happy with the reason that I've said we ought to make sure that we write so that we can be just relevant? There's a document,
Yes,
guys,
sir.
that's called the acceptable reason document. It basically has the statements and the reasons that basically they try to harmoniously use across all the provinces so that there can be some uniformity in the way that we write our reasons. So I would say it's very important to familiarize yourself with that. But I think obviously, depending on the teacher and what you've been taught and stuff, maybe some will be okay if they know that your reason is around the ballpark of what they would have wanted. So yeah, but I'm not gonna lie, as a maths gamer who does and hosts these live lessons, I really encourage use of the reasons in the document. Document is called, it's the exam guideline. So if you go to the exam guideline for maths grade 10, you can get it on Google, guys. I mean, it's a PDF maths document, exam guideline. You will page through, there is a section that's called acceptable reasons. You need to go there, you page through it, acceptable reasons, the acceptable reasons are there. Okay. All right, let's go on. Write down the value of b in terms of x. Now, when they say write down something in terms of something else, it means that the answer will not just be a number angle. You will have the number, but in the midst of that number, you are going to have terms of x. Okay. So where is b? Here is b. All right. So they want you to write b in terms of x. So what are you thinking, Austin?
So we're gonna say b plus 5x minus 40 is equals to 180 degrees.
Okay, say that again. You said b.
B plus 5x minus 40 is equals
b
to
plus
180 degrees.
5x minus 40 is equal to 180. Is Maite following what
Yes, sir.
my good friend Austin said?
Yes,
Do you
sir.
understand why he said what he said?
Yes, sir.
Are you sure?
Yes, sir.
Reason B.
Straight line. Angles on the straight line.
Yeah, yo, she understands. Yo, jo. Yo, she understands, buddy. She understands. Go, Maite. Woo. All right. Write down the value of b in terms of x. So we have b plus 5x minus 4 is equal to 180. Then, what are we going
Then
to
we're
do?
gonna say B. We transpose a negative 40 to the other side.
We transport just the negative 40.
Oh, and 5. Yeah, minus 5x.
X.
5x. So what does it become on the other side, guys?
Negative
Negative
5x.
5x.
Negative 5x, very true. Thank you, Dumiso, for the roses, buddy. Really appreciate it. You transpose the 5x, it was positive, becomes negative, then?
Positive 40.
Positive 40.
The
Thank you
negative
so much.
40.
Then, like terms? Any like terms then?
Then we what we call? Yes, they are 180 and
Tell
40
me.
are like terms.
What is it?
180.
What's the sign?
180 plus 40 degrees.
Which is?
Then it gives us 220 degrees.
220 degrees.
Minus 5x.
Yo. Jo. These guys. Jo. Hi guys, you don't mess around. Aye, you see this pair. Hey, this pair. Okay. So now let's just check again. They said write down the value of B in terms of X. Thank you so much for that, Rose. The B is really in terms. You see how many terms you have on the right hand side? You have two
Yes.
terms, right? You have 220 degrees, which is a numerical value, and then you have negative 5x. So really and truly, this is answering the question spot on. The value of B in terms of X. We shouldn't be ashamed that B is not just given as a numerical value, because that's what they asked. B should be in terms of X.
X.
Yeah, labels. Look at this 3.2.3. Clue giver.
If B equals to
Which is what we just got, right?
yes.
What are they saying now? If B is equal to 220 minus 5x,
Prove that RC equals to
Rx. So let's go and check. Where is RC? Here is RC. Where is Rx? Here is Rx. So if we want to prove that RC is equal to Rx, isn't it important that we would have to prove that this angle and that one are actually the same?
It is.
Because if we can prove that, sorry guys, sorry about that. If we can prove that this angle and this angle are the same, then closed case, this side is equal to that side.
Because opposite angles of an isosceles triangle.
Exactly, ne? So before that, let's just check. They are saying if B is this, we need to prove that RC is equal to Rx. All right. So that means we know for a fact that this here, we just were told, is what? 220 minus 5x. Ne?
Yes.
Yeah. So we have that angle in terms of x. We have C in terms of x. We have this angle. We had gotten this angle, remember? We updated our diagram. We know what this is.
Yes.
So then what do we need to do? You tell me.
So can't you add all the sides and say equals to 180, then you see interior angles of a triangle?
Image, back up a little bit there. You said add all the what?
Like you say, like you add all the angles inside the triangle.
Oh, thank you. You are now saying the right thing, because initially you said add all the sides.
Oh, sorry, add all the angles of the triangle.
Yeah.
Then you
Yes.
say equals to 180. Then you see interior angles of a triangle add up to 180.
Okay. All right. Let us explore that. I like what you are saying, but you can never be sure. We'll see where it leads us to. It's nice when we are doing these questions to take that leap of faith, and then we see where does it lead us. You see what I meant about these people? They are so persistent. These people, these funny people. Yeah. My goodness, are you kidding me? It's a fight. It's a fight there, guys, in the comment section.
Have you seen beautiful cars? Like,
yeah, we need to. It's like they are coming here to be detractors. Okay, so let's take all the angles. So what do we have then for the angles of the triangle? We have what? B, which is?
20 minus
220.
5x.
So in triangle RBC, xc. We have b, which is 220 degrees minus 5x. We are going to add that to
Plus
Our
2x
plus 2x
plus what?
plus
and our
8.
8.
Plus 80. So we're going to say 2x plus 80 degrees is equal to, you said equal to what? Maisa?
180
108.
degrees.
180 degrees. And you said the reason is?
And
Sum of
interior angles of a
in triangle.
triangle.
Very true. Int angles, triangles. That is obviously short form, but yes, interior angles of triangle would be 100% correct. Okay. Then,
We add like terms.
okay, so negative 5x plus 2x is equal to 180 minus 80 minus 220 degrees. I've transposed everything, kept the x values on one side, transposed all the angles. What do I get on the left?
Negative
Negative
3x.
3x.
Thank you, negative 3x. On the right,
100. 100. 220 minus 100. Negative.
Negative 120.
negative
Ah,
120.
negative 120. Okay, negative 120 degrees. We then do what at this point?
Divide
Then you
all
divide
sides
by
by
three.
Great then. We divide by?
negative
3.
3.
Divide by
Anyway,
negative 3. The
negative
coefficient
3.
of
That's
the
right.
x value is negative 3. So we divide
Yeah.
by that same value. Left and
Okay.
right.
Right. Then you're gonna get x on the left hand side, then on the other
Which
side,
is
3, 6, 9, 12,
40 degrees.
40 degrees, positive 40 degrees.
40 degrees. That is positive.
Amen.
We now have the x value. We go back to the triangle. We look at
Then you
who
put in
now?
brackets. Then you look at, I get to see it's 2x, then like you're gonna substitute the x with the 40.
Angle C is 2x, but we substitute the 40 degrees, we get
Degrees. 80 degrees. Then it's gonna prove to you that it's an isosceles triangle because both of the angles are equal.
Okay,
At the
so that
bottom.
means angle C is equal to angle. Now, what did they say it was when they specified a angle RXC? RXC, this one. Angle RXC, which is equal to 80 degrees, right? And then, remember, they wanted us to prove that RC is equal to RX, so then we can conclude and say, therefore, RC is equal to Rx, but the reason that we are saying so is sides opposite equal
Isosceles.
angles.
Angle.
Yeah, because the notion of isosceles triangle, okay, if you look at that acceptable reason document, it says in order to prove that two sides are equal, you must prove that the angles are equal, right? Which is like those angles that, yeah. So the sides opposite equal, the sides are equal because they are opposite angles that are equal. So we say sides opposite equal angles as our reason for saying RC is equal to RX. Okay.
Yes.
Yeah. Otherwise, the mathematics that you guys conducted is very good. Maite, you are surprising me because initially you kind of made me feel like, ish, there's a lot there that we need to be. So now I'm like, hey, bo, so this person knows these things. It's like, Jomate.
Yes. So we didn't do special angles like in our school. So yeah, that's why I was confused.
Oh, okay. No, it's fine. No problem. At least I get you. Now I understand why you were harassing me. I've never seen someone, what you might call, spam me so much. my soul.
Seriously.
Yeah. Okay. Let's move on to the next question. Question 4. TPQR is a parallelogram. TR is parallel to PQ. PT is parallel to QR. And they are saying use the diagram above, prove the theorem which states that the opposite sides of a parallelogram are equal. So this, guys, is not a question that is, it's more of a proof. There are proofs that you need to know, so there are theorems that are related to parallelograms for your quadrilaterals that you need to know. You can see the brown sugar mother is like saying theorem 2 question mark. So I want to ask you guys, both of you, have you done the theorems that relate to parallelograms?
So
Midpoint theorem, that we only did
No,
triangles.
not midpoint theorem. Yes, midpoint theorem is a theorem, but it's not a theorem that relates specifically to the properties of a parallelogram. So there are theorems that relate specifically to the 5 properties of your parallelogram. That's what I'm asking. Have you done the theorems that relate to those?
we didn't do them. They just
Yeah.
taught in my school for me. Like they only taught us the properties of parallelograms and all other quadrilaterals.
Okay, so I'm going to show you, but here's the thing, okay? The way that we do these is we use the concept of congruence.
Congruency.
Yeah. So here, congruency is going to assist you to be able to prove. All right. So let's just look at it practically, because I know some of you are well, if you're going to look at this, all right, remember what you've been given are just the parallel lines. Okay. Yes, TPQR you've been told is a parallelogram, but we want to use the diagram to prove the theorem which states that the opposite sides of a parallelogram are equal. So after all is said and done, we are going to look at 2 triangles. Which one?
So triangle triangle TPR and also triangle PRQ.
Thank you. So I'm going to say TPR,
In triangle.
triangle. So we're going to say in triangle
Triangle.
TPR and triangle.
TRQ.
So if you said
angle,
TPR,
sorry.
remember we
Q.
moved in the direction of the parallel lines, and then we moved
Okay.
to the common side back to the single. So we are going to say, if we said TPR in the same order, we are going to say this side R,
QP. Wait.
or QRP.
Yeah.
Yeah, because if you say TPR, then here we have to say QRP.
Okay.
Sir,
Yes.
sir. What if you name the triangles wrong? Instead of TPR, you say RTP or something.
So for now, in the identification, so don't worry. For now, in the identification of the 2 triangles you want to prove, we have not yet stated that they are congruent. It's just that when you state their congruency, that's when the order of the letters needs to be 100% correct.
Okay, understood.
Yeah, so but the thing is, I try and make sure that even from the get-go, I get the order correct so that I don't have to struggle at the end.
Okay.
Yeah. So we have triangle TPR and triangle QRP. So then what do we do then for the purpose of proving
you see-
congruency of these triangles?
So say
So you,
how I usually start, I would say PR is equals to PR, reason being common side.
Do you agree with that?
yes, sir.
Wait, PR
Yes,
is equal to PR. PR equal to PR.
Common side.
Reason, common side.
Then I would
Then
say
TR is parallel to PQ.
Okay, wait a minute. Let's explore what Maite has said. If we say PR, Maite, you said PR is what? Or what
So I
did you say?
said, I said TR equals to PQ because they said nowadays the memo said you must give like the parallel lines. If you don't give the parallel lines, then they're gonna mark your reason wrong.
Yes,
your answer.
but that applies to something else, eh? That applies to
Angles.
when you are identifying angles corresponding co-interior alternate. You have
Alternating.
to make
Okay.
sure that you write your parallel lines as well. So we can't use that though at the moment to basically support congruency.
Answer.
Remember, we've identified a side. There are how many cases of congruency, guys? There are how many cases?
it's okay.
We have 4 cases of
6,
congruency.
7.
We have SSS, side,
SAS.
SAS, side, angle, side,
A.
AAS, or sometimes SA, or ASA. And then the last one, RHS. Hence, I'm saying 4 cases, right? AAA is not a case of congruency, guys. That is a case related to similarity. It is not a case of congruency. AAA is not a case of congruency. It is a case related to, yeah, please guys, please, let's not do such. Okay, let's go. What then else can we identify? PR is equal to PR, common side. What else can we identify?
So, are we gonna say angle P or P1 or angle TPQ or
Angle
TPR?
TPQ. TPQ is this angle, this entire angle. Are you wanting to talk
Yes.
about that angle?
No,
Are you sure?
I mean, you see, we can say P1 and P2, but they didn't give us the number.
We don't use those unless we actually, because of our construction, we basically name them as such. But if they are not given, my guy, then basically you need to use your arms to identify the angles.
Okay.
So you were saying something though. I liked what you were saying. You just need to complete it. So to identify the angle, we can say angle TP what if you want to identify that angle. That is if you want to identify that.
Isn't it? Sir, can you please move your camera so I can see?
Oh, sorry about that.
TPR. Hey. Or TPQ, I'm not sure.
TPR, TPQ. Seems like you are saying many things. TPR, TPQ.
So I'm not sure which angle to use.
Okay, TPR. This angle is going to be equal to which one?
TPR is going to be equal to. We did say something.
So
TR.
PRQ.
PRQ. Are you in agreement?
Yes.
TPR, this angle, is going to be equal to PRQ. Or you can say QRP. It's really up to you. Okay. TPR is equal to PRQ. What's the reason?
Alternating angles.
Angles.
All right, now you are going to include your parallel side as well.
Parallel
Alt
lines.
angles, then we state the lines are parallel. Which ones?
TP parallel to PQ.
Okay. PT parallel to QR. Because of course that's what they gave us. So we are using it. Okay. Yeah. Please guys, you can't just write. So that's what my what you were saying is 100% correct in this situation. Because in this situation we have to write alt angles, but then we need to also identify the lines that are parallel. If you don't,
Yes,
then it's
sir.
incomplete. But when you do, it's complete. So identify the parallel lines. You are 100% flowing with it there. That's our first angle. Is there anything more?
Oh, yo, sir. Let's see.
Anything else?
See something, man. TP.
What about this guy and this guy?
That guy.
Yes.
But then how can
Angle QRP.
Angle Q what? This angle
Isn't it?
and that angle. Those are also alternate.
Yes. The problem is naming them, sir.
TRP. Angle TRP. Okay. Angle TRP is equal to what? Angle QPR. Or you can say RPQ. Middle letter denotes the angle. So we can say RPQ. RPQ. Reason there?
alternative?
Alt angles. Which lines this time round are parallel? Because we need to identify the right lines. The Z.
TR and PQ.
TR is parallel to?
PQ.
Exactly. TR parallel to PQ.
Then we
This is
conclude
our-
and say angle.
Sir.
Then we conclude and
So-
say triangle PQR congruent to triangle QRP.
So
There is a
triangle
reason.
TPR is congruent to triangle QRP. Reason.
Sir.
Side angle side.
Side angle angle.
All side angle source. Yeah.
Yeah. So you can see, guys, that when I write my statement and my reason, I also include that small letter that indicates what I have identified. It's a side, it's an angle, so that it can help prepare my case that I'm going to support at the end.
Yes, sir.
Yes.
Yeah. Now, guys, since the two triangles are congruent, since this triangle is congruent to this one, then it stands to reason that this side should definitely be equal to that side.
And that's it.
And that side is definitely equal to that side. Because these triangles cannot
Are
be
congruent.
congruent unless this side and that side. Okay. Yeah, I'm so worried about my eating. Hey. My. Yo,
Bakula friend.
my. Hey, I'm worried. Yeah, I'm worried now. You? I'm worried. You? My.
So how many marks is this? It's 4.
Yo, and then she speaks about marks, but yet I'm worried. Hey. We're not done, mate. We're not done.
Oh, you're gonna first
When
say
you
that
get
they
here,
are parallel.
Remember, they were saying use the diagram to prove the theorem which states that the opposite sides of a parallelogram are equal. Then you can say therefore at the end here. The thing is, TP will be equal to QR. You see this first two? TP is equal to QR. Also, yeah, we know PR is equal to PR as has been stated, but also, and that's the common side. You see PR and RP. Then TP is equal to QP. TP. What am I saying? TR is equal to PQ. Sorry. TR is equal to QP. TR is equal to QP. So that's basically supports this thing of use the diagram above to prove the theorem, which states what? That the opposite sides of a parallelogram are equal. So by using congruency to prove that the two triangles are equal, we were able to get to a place where the two opposite sides, the opposite sides indeed, the pair of opposite sides, both pairs of opposite sides are actually equal. So we end right there. The theorem has been proved.
Yes, sir.
Yeah. Okay. All right, man. All right, it's happening. Okay. So guys, there's theorems as well. Okay, and I need you guys to be able to make sure that those theorems you can also do. Then we can conclude with this question, guys, and I'll call it a night because I feel like I overstayed my state. What do you mean, Ase?
Say please.
Aibo, Maite, what's your problem? And you're saying Ase. Ase what?
Say please.
What
Say
do you
stay for a
mean,
few
please?
minutes. Okay.
Please what?
Say like question one. Say okay, but okay, it's fine. I'll ask after. There's only one question that I want to know about. Because I
It's
came
fine.
like when you're doing
We
question
can go
2
gallop to your question, Maite. You can go to your question. But
Okay.
let's first conclude. Let's conclude. I want to conclude this question.
Yes, sir.
Hey, this girl wants me to stay here forever. Camp with her. What is this? 4.2. What's happening now? Hey, people making funny noises here. What's happening? Okay, ABCD is a square. ABCD is square. Diagonal AC and line BGE intersect at G, right? And angle EBC, EBC, this angle here is 40 degrees. All right. Now, the first question is saying, calculate with reasons the size of angle G1. Okay. I'm going to allow you guys to share if you have anything. So I'm not in a rush, all right? And we don't need to be, because it's good to think and allow yourself to think. They said ABCD is a square. That says a lot, guys.
So, diagonals of a square bisect perpendicularly.
Wait a minute. You are saying what?
Diagonals of a square bisect perpendicularly.
Yeah, but wait a second. You are saying diagonals of a square. Is AC a diagonal? Yes. Yes. Is there another diagonal? So that's the problem. We don't have actual diagonals of this square that bisect at 90. Okay. But I like what you are saying. Diagonals of a square do bisect at 90 if we have them, both of them.
Say
yes, Maite.
Can't you just say 40 degrees plus G? Oh no, I'm wrong. Never mind. That's fine.
It's fine.
40 plus B plus C. is equals to each other
B
because
plus C is equal to each other.
yeah, I think then 40, 40, 40, then it's gonna be 80. Then G is going to be 80. 90.
Okay,
It's going to
you
be
guys can check
120.
out. There's a lot of people that are commenting as well in the comment section. Your boy Bless says 40 plus B1 is equal to 90. That's what
Oh
your
yeah.
boy Bless is
Oh
saying.
yeah, that makes sense. That makes sense. It's cause right.
Yeah,
Okay.
But then the question is, how will that be useful in finding angle G1?
You okay?
Yeah, and I'm not saying anything, but I'm just saying, as you do that, is it going to be useful? Does it help? If it does, then great. If it doesn't, then yeah.
Yes.
People
So
are
you see,
saying-
BBC Gene. That's what I thought, because I thought like 180. Like if you think about it, like it makes sense. But then I can see that B2 is like on the outside. Like it's not. I don't think it's part of the straight line.
Okay. There's something that you guys are refusing to see, and it's actually in your face, but it's hidden, but it's in your face.
So the letter F. Wait, G2 is letter I don't mind.
Okay, someone is
Alternating
asking,
now.
is G140? Is G140? Are you asking me? Tell me.
G1.
Is AC a diagonal?
Yes.
What do you know about the diagonals of a square at the corner?
A right angle.
At the angle at the corner, what do they do?
Isn't it? Oh, never mind.
They bisect the corner angle.
So what will be the value of those angles there at the corner?
If not given, it will be 45, 45.
Yeah, but this whole entire angle will be what?
90 degrees.
Yeah, and obviously A1 and A2, since we know the property of the diagonal of a square. C1.
So I'm saying.
We know C1.
So I'm saying. Oh, never mind. So I'm saying 40 plus 40 equals to G2 because corresponding. Then 40 plus 1 equals
sorry? Say that again, you
then
say?
40 plus G, ne?
Plus G.
It's G is 40 because of corresponding, right?
Okay, listen very well. Corresponding angles are equal if lines are parallel. Do you have lines that are parallel? This line, is it parallel? Well, AC is the line that is parallel that you are talking about. But what is it parallel to that you would say this angle is equal to that one?
Okay.
Because remember, this C is not parallel to AC. Do you hear me, mate? Yeah, so parallel lines need to exist in order for you to say that, but in this situation, it's not the case. So there's a lot of things I'm just bringing things to light, and nothing much, okay? So if, as I was saying, this is a diagonal. If ABCD is a square, that is 90. But these two angles are both 45 degrees. Okay? This angle plus that one should give me this one. What is this? Interior opposite angles of a triangle. They give me, the sum gives me the exterior. This angle that is here. Yeah. Or I could say 45 plus 40, get this angle, and then use vertically opposite to get G1. Why does it seem like you guys are like, wow?
No, sir. Angle G is equals to 85 degrees exterior angle.
Exactly. It is
Then
85.
then angle G1 plus angle G, they're on the straight line, so it will be 180 minus 85 degrees. It will be 95 degrees.
So you're saying G1 is 95.
Yes.
Okay, let's unpack it one step at a time. So as I was saying, guys, this AC is a diagonal. Okay. Hopefully we can all agree. AC is a diagonal.
Diagonal.
One of the properties of a square is that diagonal bisect corner angle. The diagonals of a square bisect the corner angle. The word bisect means to cut into half. Okay, so we can all agree that angle C, DCB, angle DCB is 90 degrees. Okay, why are we saying DCB is 90? It's because we know most angles of a square.
Yes.
Yeah, interior angle. So in one angle, interior angle of a square is 90, right? So that means angle C1 is going to be 45 degrees. Why do we say angle C1 is 45 degrees? Diagonals of a square. Okay, so that means C1 is 45. So if you look at this triangle, it means you can get angle BGC if you want. Okay, angle BGC, you can get that if you want. BGC, because that's in triangle. So let's just say in triangle BGC, in that triangle, we have 40, we have the 45 that we just got. Does that make sense? And then we have this angle BGC, which we can find. So we're gonna say angle BGC plus angle GBC plus angle C1. That will give us 180 degrees. Reason interior angles of triangle. Or you can say sum of angles in a triangle, or you can say angle sum in triangle. There are three acceptable reasons to use for the interior angles of a triangle. You can say sum of angles in a triangle, interior angles of a triangle. You can say angle sum in a triangle. So BGC, G40, GBC, BGC is what we want. Okay, we don't know that yet. C1 is 45 degrees. We transpose, we solve 180 minus 85. What's 180 minus 85?
95.
95.
Yeah.
95. Okay, I think we're making her cough when we do these things and make her laugh. Are you sure it's 95?
Yes.
Yes, very sure, eh? Then we use the idea, these are lines that are intersecting. It says must BGE, you guys said BG intersects at G, all right? So that means AC and line BGE intersect. So if they are intersecting lines, that means
Vertically opposite
G1
angles
is vertically opposite to this one.
to 95,
Yeah.
which makes them equal.
Yeah. So BGC is equal to angle G1, which is equal to 85. What's 95? Sorry. What's the reason?
Alternating.
Vertically
Vert
opposite
op
angles.
angles equal. Vert op angles. It can't be alternate angles. It's vert op.
It's a mistake.
No problem. And every time we're getting answers, we're updating. 45 degrees is now there. 90 is there. 95 is there. 95 is there. Okay. So I don't know why Baby Clay is saying, no, Baby CJ, GTA. No, it's 85. I don't know why.
Sir.
Yes.
Yeah. Can you shift the camera so we can see?
Shift the camera so that you can see the diagram.
Yes.
So what's the
Yeah,
next question? What are you looking for?
So say
Sorry?
if we use exterior angles of a
Yeah,
triangle
that could
to
also
find
work.
G.
That would also work. So you use exterior angles, meaning you say 45 plus 40. Then you
45
get
plus
angle, EGC, this angle. Remember, you're not going to say it's angle G, you're going to say it's angle EGC.
Okay, yeah, sir.
Because G is everything. Yeah. So you will get the same answer. If you use exterior angle, still the same thing. You say these are the two interior opposite angles. Remember, there's that theorem that says, that triangle thing that says the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So you could do that as well. Okay.
Yes.
Yeah.
It gives us
Then you
the same
subtract
answer.
from 180. Then you subtract from 180. You get the same thing. Yes, flavor of full sense. Very good. You subtract from 180, you get the same answer. It works.
Yes.
It works beautifully. Next question, they want us to find angle E. It should be straightforward, that one. We have this guy. We can get this guy. Surely we can get him.
So then it will be 45 plus 90.
45 plus 95 plus that E.
35.
But first, we need to state that angle A2 is equal to 45. So there's the steps we need to take, because we can't just throw it in there. Yeah, we get angle A2 is equal to 45 degrees by first establishing that angle DAB is 90 degrees. Obviously, that's because of the fact that angles of a square. We then establish that A2 is equal to 45 degrees. We know diagonals of a square bisect. Corner angles there, and then we say 45 plus 95 plus angle E 180. Then we can subtract and get the angle.
Yes.
Yeah, and at every turn, when we are writing something new, we write the reason to accompany it. So flavorful sense says the angle E is 40, right? Yeah, but let's look at something else that we could say. You see this angle, yes, type, very good. Type saw something else. This angle, because we were told here that, this angle and that one. Because if that is a extension, or it is produced D to E, okay, then of course that AD is parallel to BC as a square. AD is parallel to BC. So obviously, if that is an extension, that means that parallel line extends, is produced. So AE is parallel to BC. Therefore, that means these two are equal alternate angles. AE is parallel to BC. Okay, that's another way.
Let me see something.
Okay, do you guys see any other way?
Yes,
Both they could be.
Both methods give us the same answer.
Yeah. What I'm asking now, is there any other method that you guys see? Because if that is 90, B1 and 40, that will be 50, this one here. Ne?
Yes.
Yes, and then obviously you know that is 90. So you're looking at this triangle. 90 plus 50 plus this one should give you 180. So what's missing there? It's 40. Still same answer.
Three methods now.
Yeah. I mean, guys, the truth is that geometry, I'm not gonna lie, that's probably one of the reasons I love geometry, because geometry, there's so many ways to basically get to answers, and it just needs you to think. If you are able to think of something and it makes logical sense, as long as it's not something like saying that the angles are corresponding but there's no parallel lines, or the angles are alternating but there's no parallel lines, you must make sure that what you are saying is actually, it makes sense in light of the sketch. Are we following?
Yes, sir.
Yeah.
Yes, sir.
Yeah, as long as that is happening, then and you can actually substantiate it with a reason, then it should be fine. All right, there should be progress in the right direction. We should be able to get to a place at least where we can say, it's correct. Okay. You write down as well what you, step by step, and then you logically present your argument. This is like an argument. It's like you're standing in front of a court case. It's standing in front of the judge. You are a lawyer. You want to prove that your client angle G1 is 95 degrees. Now you take it from the beginning and you state how it is that is the case. And at every argument that you make, you are giving evidence and reasoning as to why you are saying what you are saying, until you are able to conclude and get to the conclusion. And then the judge looks at you and is like, no, your argument has been very strong. I think I'm going to pass judgment based on your findings. We can clear your client. You are free to go. Thank you very much. Full marks. Yeah. So let's look at the 4.2.2, guys. All right. I didn't write down anything to find the angle E, and I'm going to leave it like that because, as I said, many ways to fry a fish. You see. Yeah. 4.2.2. They are saying if AB is root 2, DE is X, show that BE is equal to this. So
midpoint there, it can be.
for how many marks? 3 marks. Remember, this is 90. They are very clever, these people.
Oh, Pythagoras.
Right?
So
But since this is
AB,
root
you're gonna
2,
square it. You're gonna
since this
put
is
it
root 2,
outside.
and this is, sorry?
So you're gonna put 2 outside the root.
2 outside the root. Just before that, before we remember, they want BE. BE is the entire hypotenuse. We have this entire side. We don't have this part, but we have that part. It's X. What is AD, guys? If AB is root 2, what is AD? What
Root
is the
2.
shape?
Root
Why
2
are
is a
you saying
square,
it's
so
also
all
root
sides
2?
are equal. All sides are
Exactly.
equal.
So that is also root 2. So that's where I would start. AB is equal to AD, which is equal to root 2. And I would say sides of a square, or adjacent sides of a square, if you want to put it that way. Because that is not actually explicitly, the value of root 2 is not explicitly given to me. Does that make sense?
Yes, sir.
Yeah, so I have to then obviously reveal it. Then I can use theorem of Pythagoras. What is this BE? What do we call BE? What do we call this?
Hypotenuse.
Yeah, so we say BE squared is equal to AB squared plus AE squared. And then we write the reason, Pythagoras, because in Euclidean geometry, if you don't write that reason, my dear, you lose marks. So when you use Pythagoras, you must always write the reason. I always tell my learners, I don't care what topic you are doing. If there's Pythagoras that you need to use, hey, you must write that reason. Yeah. B. Yeah, I'm telling you. Yo.
Oh, good.
Yo. Hey, guys. This girl, I'm telling you. When I'm a eater, you'll be the death of me. I'm telling you. In the life. Then AE, we are going to say root 2 plus x, the whole thing squared. Ne?
Yes, sir.
Yes, sir.
Then BE squared. So we can go ahead, square the square root of 2, which is what? 2. Plus this, we are going to play Mr. Foil. We know Mr. Foil.
So what's Mr. Foil?
We open two brackets, Kalog, and we foil. Multiply the first term,
Okay.
multiply outer, multiply inner, multiply last. We don't square the first term and square the last term. We think we are done. No.
Oh,
The
yes.
shortcut, we square the first term, 2. We square the last term, x squared. The product of the 2, and we double it or multiply by 2. So this is like 2 root 2x. Root 2x is what you get when you are multiplying these two. Then you double it. That's 2 times the 2 root x. But the x is outside. It's not inside the root. Does that make sense?
Yes.
Yes. So if you want to foil, please go ahead and foil it. You should still get the same answer, 2 root 2x. Any like terms in the mix? 2 plus 2, yes, give 4. Plus 2 root 2x
plus
x squared. Okay. Yeah. Can you see what you are seeing there? It's like we are coming close. We just need to order our terms. We just need to put them in the order that we see them there. But we are close to paradise. Then we take the square root on both sides. Why? Because we want to get rid of the square. We don't want BE squared, we want BE. Okay. Then we going to write it in the order. X squared term first, followed by the x term, followed by the constant. Give you deeds.
Get remarks.
Okay. So then I get my full marks and now go out of the way. Paper 2, we're so happy. Celebration, 100% once again. So nice.
Thank you so much.
Maite, you've had that checked out, right? Because
Say. Yo,
and
so
how long
this
has
is
it been? I'm gonna be your doctor now. How long has it been going on, this cough?
since last week.
I might die. Please go check that out, man. Please check it out. I don't. You must, but don't delay it. It seems like you're gonna keep on putting it this thing off. Don't put it off. It doesn't flow so well. It doesn't feel good, this thing. Okay, so now what is your problem, Maite? Because when you were like, please say this question, what question?
question.
What do you want? What do you want?
So can you see how question 1 looks?
You wanted to see what question 1 looks.
See, wait, what's this memo for?
I told you, Mos Maite, this is not the question paper you'll be writing tomorrow.
Yes, I just want to see like the example, like that. Oh, you're doing okay. This is analytic. Determine the quantity. Okay, sharp. The length I know. The midpoint of PR. Okay, midpoint is x1 plus x2 divided by 2. Okay. Determine the equation of perpendicular. Perpendicular, it's supposed to be equals to 1.
What?
Negative
What is
one.
supposed
Okay, but yeah.
What's that? What's supposed to be equal
Like,
to 1?
so let's say, like, in the exam paper, they say, like, prove that line AB is perpendicular to line BC. Then you're gonna have
That's
to calculate the gradients. Then you times them together. Then they must be
Oh,
equals
okay.
to -1.
Oh,
Product
okay.
of the gradient.
That's fine. Product of the gradients is -1 indeed. What about parallel lines?
The gradients are equal.
Yeah, I was asking Maite, are you sure as well that you know?
See, I just knew now. I only knew about the perpendicular one.
Yo. Okay, I
Yeah.
did not. This is another paper that I have on here.
Calculate the length of AD. Okay, AD is easy. Show that A is A. Okay, A equals to 10. So how did you calculate? Oh, so you're gonna say from A
This
to
is literally a paper that I'm just showing you now. I didn't do this here. I'm just showing you this part of the analytical geometry because there's questions that are different from the paper that I did just now with that.
So you see with A, question 3.3, I think you see you're gonna see like what you did to get to D because it's a parallelogram, right? So opposite sides are equal. So you see, so it's -8. So you did, what's this? We didn't see -8. So you plus with 8. You plus with 5 to get to the x of D. Then okay, sharp. So this side you're also gonna plus with 5. So -1 plus 5, it's gonna be okay, A plus 5.
Yeah, what
right?
is -1 plus 5? Come on.
-1 plus 5 is gonna be +4. Okay, that I understand.
So the A value is equal to what?
The
Can't be.
A value, it can be
They
-4.
want the A value.
Oh yeah, it can be -4.
They want you to show that A is equal to 10.
It's 5. Am I crazy? Never mind. So what did you do there? Distance formula?
This is -8. So the -8 to 3. What's 3 minus -8? Isn't that going to give you 11?
Oh yeah, of course, I'm going from the other side. Oh, okay, yeah, right. Okay.
So then if it means so that means you can add 11 to -8 to get 3. So the same thing you will do here, you add 11 to -1, you will get what?
You'll get 10. What's this 10?
Exactly. Yeah. But you see, the thing is now here, so that's by inspection. But I think the logic that they want you guys to apply here, or not the logic, but the calculations, because if they are saying show, then they want to see actual calculations. So you calculate the length of AD in set form, you leave your answer as a rational set form with a square root, simplified, of course, if it is simplifiable, not simplified if not. It just depends. Determine the coordinates of K. What is K, my dear?
It's the midpoint of AC.
Yeah. Yes. So you use which two coordinates to get K?
You're gonna use either AC or DK.
AC is out of the picture because you don't have
Oh, DB. Sorry, DB.
DB because all the points and the coordinates are there. Only DB, right? Yes.
Yeah.
You get the midpoint, but isn't this midpoint also the midpoint of the line AC, as you said?
It is.
Yes. So they want to see you use the end point. The given midpoint you will have the coordinates of K. So then if you have the midpoint, you can find the end point of the x coordinate. If you have the x coordinate there and the x coordinate there, you can find the x coordinate there.
Okay.
Yeah, so
that
that's
is
what
I
they
understand.
want. Yeah, so they want to see that. They want the application of that. So I know Maite, I know you are good at inspection. I have no doubt in my mind you are good at inspection. But the thing is, because they want you to show that A is equal to 10, they'd rather have you actually find the end point if you are given the midpoint. You know how to do that. Because you say the x coordinate of K will be equal to the x coordinate of A, which is this side, plus the x coordinate of C over 2. Then you substitute. -8 will be there. K you will have there because you will have found it. Ne? And then C is going to be that A value. Then you solve the equation. Cross multiply, answer.
Yes, sir.
Yeah, so they want to see that. So show, my dear.
Yes, sir. Okay. Yeah, so this one I understand.
Oh, you understand?
3.4. Sure. I said 3.6.
3.4, you understand?
3.4.
DK and B are collinear.
I'm gonna have to. Okay, never mind. I'm gonna have to determine that. Never mind. DK and KB have the same gradient.
DK and
KB.
That's fine. If you calculate the gradient of DK and the gradient of KB, what do you expect to get so that they are collinear?
Let's see. This is DK versus DK and what KB. I'm gonna have to get like the same gradient, -1.
Yes. If the gradients are the same, if the gradient of DK, you get it, and you find that and you get the gradient of KB, and you find that those two gradients are the same, then you can conclude and say that DK and B are collinear.
Okay.
Yeah. Okay. Equal gradients imply that the points are collinear. I mean, you could do a combination of, you can either do the gradient of DK and the gradient of KB. Get the both of them individually on their own, and then you conclude about their equality, and then you then say that the points are collinear on the basis of equal gradient. Yeah. So
and then 3.6.
Imagine before that 3.5. What about 3.5? Because now you are saying 3.6, but me, I'm wondering 3.5.
What are the properties again?
Hey, Maite.
What are the I don't know. Wait. And it's how many marks? 5 marks.
Yeah.
So how did you prove it?
These are the questions that have marks.
So how did you prove it?
Just wait, let's see. And I'm interested to see what you guys think. Oratile.
Hello, sir.
How are you doing?
Good evening, sir.
I'm doing very well. There at 4.5, 3.5. You've been listening, Mosne? Or not really?
Not really. I've been a bit distracted.
That's fine. What are you preparing for? Another test? Are you preparing for something else?
No, I'm also writing maths paper 2 tomorrow.
Nice. Okay, do you know how to prove that a quadrilateral is a rhombus?
We can prove one of the properties.
Which is what?
The diagonals of a rhombus, they bisect the angles.
They bisect the angles. How do you prove that the diagonals bisect the angles using analytical methods?
I'm not really sure about that. So
that one, Radil, I'm just trying to prove to you that one is not going to work. Because using analytical methods, like we this is an analytical geometry question. So we are trying to use analytical methods to prove that ABCD is a rhombus. So already we know ABCD is a parallelogram. And what do we know about a parallelogram as far as its diagonals are concerned?
Okay, what we know about a parallelogram is that the opposite sides are parallel and equal.
Okay.
So we
See,
can prove that they are.
Okay, I hear you, but I'm just asking specifically about the diagonals.
Okay.
What do you know about the diagonals of a parallelogram?
Okay, like I said, we know that they bisect, and then we also know that
they bisect each other. So how do you prove if this was a quadrilateral and I said prove that it is a parallelogram? The quickest, shortest, and most effective way to prove that a quad is a parallelogram is to use the concept of diagonals. Now, I know, guys, there's many other ways, but you see, when you are writing a paper, you want a quick in and out. You don't want to sit and stay and waste time. So the property to prove that a quad is a parallelogram is to prove that the diagonals bisect each other. How do you do that? By checking if the midpoints are actually shared. How do you do that? You will calculate the midpoint of DB, right?
Yes.
Get it? Then calculate the midpoint of of AC. Then you will, if you get the same midpoint, then you can conclude that this is a what? A parallelogram. Are you with me?
Yes, sir.
Yeah. So this is the quickest way, because if you are going to calculate the midpoint of this line and the midpoint of this line, how many calculations have you performed?
Sir, can you please repeat the question?
I'm saying if you have calculated the midpoint of DB and you calculate the midpoint of AC, how many calculations have you performed?
2.
Just 2, right? So that's 2 calculations. The minute the midpoints are the same, you say that the midpoints are shared, then you can conclude that this is a parallelogram. Reason, diagonals bisect. Done. Finished. 2 calculations, ne?
Yes.
Yeah. That's proving a quad is a palm. Now, we are already told that this is a parallelogram. What they want us now to prove is that ABCD is a rhombus.
So can I ask?
Yes, you can. Sure, ask.
So sir, how about I find the gradients of any pairs of
The
two opposite sides if
Yeah,
they're
yeah,
equal.
That's fine. That's fine. You can do that. But my question is, how many calculations are you going to be doing? It's the gradient of this side, 1. The gradient of this side, 2. You are going to have to also find the gradient of this side, 3. Have to find the gradient of this side, 4. Because that one, you are using the property of both pairs of opposite sides are parallel. So that's 1, 2, 3, 4. How many calculations?
5.
4 calculations.
4.
4.
Sorry.
If you are going to use the property of both pairs of opposite sides are parallel.
Parallel.
Yes. So 4 calculations. I mean, you can do that. That's fine. You can prove that a quadrilateral is a parallelogram using both pairs of opposite sides are parallel. But what I'm saying is there's a quicker and effective way of just using the diagonals. You calculate the midpoint of one diagonal, you get it. You calculate the midpoint of another diagonal, you get it. The minute you see that the midpoints are the same, you conclude the quadrilateral is a palm. Reason, diagonals bisect each other. Finished. 2 calculations. Okay. But here it's really, like I said, guys, I mean, at the end of the day, it doesn't really matter. If you want to use both pairs of opposite sides or parallel, you can do that. Okay.
So then, sir, we only check
Yes.
one property.
Sorry?
Do we only check one property of a
Yes,
rhombus?
yes. For a parallelogram, you only check one property. You could use, for instance, both pairs of opposite sides are equal to prove that a quad is a palm.
Okay, so
If you're saying opposite sides are equal, it means you are going to use distance, distance. Distance formula, two calculations. Distance formula, that's a total of how many calculations?
2,
Uh-uh.
5, 4.
Distance formula, 1. Distance formula, 2. If the two are equal, then of course, that's one pair of opposite sides equal. Distance formula, that's another pair of sides that are equal. So that's 4 calculations in total. 4.
Yes, sir.
Yeah. So for me, like those ones are really like I feel like it's you draw out. It's a lot that you do. But if you use the diagonals bisect each other, it's 2 calculations and it's done. Right. Now we were kind of coming here. If we prove that a quad is a parallelogram, that means the diagonals bisect each other. In order to prove that that parallelogram is a rhombus, we need to prove that those diagonals, you know that they already bisect each other, but you need to prove that they bisect at 90. How do you prove that the diagonals bisect at 90 specifically, 90 degrees?
By taking the gradients, then multiplying them to see if we get
Exactly.
-1.
Exactly. So you would have to calculate the gradient of one diagonal, calculate
Yes.
the gradient of another diagonal. Then you multiply them together and check if they give you -1. If they do, then you can conclude that the diagonals of this particular parallelogram, they do bisect at 90, which means this palm is a rhombus.
Okay.
Are we together?
Yes, sir.
Yes, sir.
Yeah, I hope we are, because so there's I literally like to say this. If you are given a quadrilateral, this is just an ordinary four-sided shape, then they say to you, prove that it is a palm. Then as I said to you, the quickest way is to use the diagonals. What do you want to prove? Diagonals bisect each other. How do you prove that? Midpoint. How many calculations? Just 2. From quad, you can prove that that is a palm. If you know it's a palm, it means the diagonals already bisect each other. So how do you prove a palm is a rhombus? Then you do what you just told me. You need to actually check if the product of the gradients gives you -1. So you have to find the gradient of each diagonal, multiply them. If you get -1, then it means that the diagonals actually also bisect at 90. So this thing is not only a palm, but if you prove that the diagonals, the product of the gradients of the diagonals is 90, gives you -1, sorry, then it means that that is a rhombus as well. So that's like a quick, short method to doing that. But if you get given it's a quad from the beginning, then you have to go through this step to get here. You first have to prove it's a palm, then from a palm, you can prove that it's a rhombus. All right.
Yes, sir.
So, yeah, so that's just something to take note of. I'm bringing this to light because I feel like it's an important thing. And you spend less time because you can see, prove that ABCD is a rhombus. How many marks is that? It's 5.
Oh.
Yeah, because you already know that this thing is a palm. So we are already actually, we are where we are at this stage. So only thing that's left is to come here, calculate the gradient of this diagonal, calculate the gradient of this diagonal, multiply the two gradients. If we get -1, what does that mean? It means the diagonals actually bisected 90. Therefore, this is a what? It's a rhombus.
Rhombus.
Yeah, that's the quick method. So I just wanted to mention that to you because it's a famous one that they like, and the quick, easy, and short is that way. I don't want to bombard you with a lot. Like I'm just gonna leave it at that. Guys, you know what perimeter is? Maite, do you know what perimeter is? Because that was the next question that basically we was here before guys, I'm gonna love and leave you after this, unfortunately, because I have to go
The
myself.
perimeter is the distance outside.
Amen, my leader. A, B, C, D, distance around. So you need the distance of each side so that you can add those distances and then check what the total distance is. That's perimeter. And they want the perimeter in what?
Set form.
In third form.
So
But you
use
see, the thing is,
distance
check what they said here. 1 mark. So what that effectively means, Maite, is that you will prove, for instance, 3.5 that ABCD is a rhombus. What will that mean? It will mean that the distance of one side will be enough. You just multiply that by 4 because all sides of a rhombus are what?
Equal.
Yeah, are equal. So that's why this is actually what? 1 mark. Because now you are thinking, yo, I'm gonna have to calculate the distance of everything. Yo, so much mark. Like 1 mark for what? Yeah, but look, already at 3.1, they said calculate the length of who?
AD.
AD is a what?
Side.
It's a side of this rhombus, right? Which you will prove at 3.5. Then all you do, you just times that side by 4 to get the perimeter. Does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Yeah. And then the last thing here, area, ABCD. You see, now you need to know the formula of the area of a rhombus. What is the formula to calculate the area of a rhombus? And it's something you need to know. The area of a rhombus. The formula is something that you can find out. I'm not going to tell you what's the area of the or what is the formula that we use, but in the use of that formula, there are aspects of the diagonal that you are going to incorporate in that formula so that you can be able to find the area of the rhombus. So you do get asked questions such as those as well in analytical geometry. They ask you to calculate the area of the two-dimensional shape. So you need to know the formulas. Formula of a triangle, what's the area? How to calculate the area of a triangle? Area of a rhombus, area of a square, area of a area of all other four-sided shapes. Kite, area of a kite, area of a trapezium. You need to know the formulas so that when asked a question pertaining to that, you can be able to, calculate the relevant distance and then incorporate them into your formula. So I'm going to leave that to you to actually go and find out, well, what is the formula that we use for the area of a rhombus? It's really not, it's not difficult. Okay. But unfortunately, guys, all three of you, I need to leave you, Orantile, Maite, and Austin. Thank you so much.
Thank you, sir.
Thank you, sir.
You've been great. You've been great guests. I really appreciate your presence. I think the people that have stuck around, they only stuck around because you guys were, I think you were great. And you guys were able to ask certain questions, which if you did not come here and ask and get clarity about, also the contribution, if you did not contribute quite the way that you did, then the people that actually stayed for as long as they did wouldn't have stayed as long as they did. So thank you so much. I really appreciate you. Appreciate all the people as well in the comment section who were commenting and who were contributing very proactively to the session today. All the best for today, because it's already like literally today, those who are writing today. Yeah.
Thank you,
I'll be praying
Thank
for
you, sir.
And thank you so much. And thank you for the roses,
Yes,
mate.
sir.
I really appreciate those too.
Welcome, sir.
Thank you. Cheers.
Zach.
Cheers, guys. Peace out. Bye. You get better, Maite, from your cough. My goodness. All right, Dile, cheers. Yo, you get better from your cough. My goodness. It's ready to send a doctor there. And you better give me an update as to like your visit. You need to go and see. Yo, my goodness. You need to have that attended ASAP. And you better give me feedback, update as to what's happening. Okay. Thank you guys for the follow, guys. My goodness, I didn't realize. Thank you for the 18.1k likes. Thank you so much, guys. Really appreciate you guys so much. And yeah, hopefully all the other things that I didn't cover in the live lesson, you guys will make sure that hopefully you will have you have covered those things as well for yourselves in preparation for today. Okay, we love and leave you. Thank you so much. You stay awesome, you stay blessed, you stay amazing. Yeah, and Tito Abenani Mudimo. Yeah. Moyo halalang. Just be upon all of you as you write.